Okay, so I should be recording now. So today we're going to do the introduction to site topography using the methods that I've been developing over the course of my career. And before we get going, I just wanted to, mention very briefly that you should have all gotten the email about the data and the workshop description that I've uploaded the box. So if you would like to follow along step by step on today's workshop, you just need to make sure you have that data downloaded. The data that I have provided is data that I've already provided in the past. I just consolidated only the files that we're going to use for this workshop into that folder there. But basically, all we're going to use for this workshop is the DEM, high-res DEM data that was derived from LiDAR data that we were given from the Montgomery County GIS department. So that's the data set that we're using. It's a pretty big file, but it's good. That's the kind of information that we want to use for this work. So philosophically, here's the reason why I'm teaching this workshop is because the way that we typically teach site modeling and the way that professionals do site modeling and the way that I see a lot of students and architects do site modeling has been completely wrong for many, many years. And here's the reason why, in my opinion, is because we're not thinking about terrain in the right way. We think everything is contours. We think everything that we do has to do with getting contour lines and using contour lines to design. Contour lines are purely a result of an existing terrain. It's a representation of the actual Earth's surface, but it's not the Earth's surface. The Earth's surface is the Earth's surface. And what we need to begin to think about when we model terrain is to not think about terrain in terms of contours, but we need to think about terrain as spot elevations. And the sooner you begin to think about your projects in that mind frame, where I need to design my project with very specific spot elevations, then you begin to actually open up the ability to model things in new ways. So that's what this class tutorial, and as we move along the semester, what I'm going to continue to emphasize throughout the semester is let's not get so focused on getting contour lines and using that as our design base, but think about more in just terms of like representing the Earth's surface with as little translation as possible from the raw data to the model itself. And that's what we're going to learn today. One fun little aside, let me actually do one quick thing. I want to bring up YouTube real quick. And I'm going to go to, I'll share my screen in a moment. So let's see. Well, for some reason it's not working, but anyway, if you have looked at my YouTube page through your class, like going back to reference class tutorials, the most popular video on my YouTube page, which I'm surprised by how popular it is this tutorial that I made several years ago for a class at WashU, where I basically taught students how to turn contour lines into a Rhino surface using a Grasshopper script. And it's one of my biggest regrets because it's like teaching students the wrong way to model terrain, which is to use contour lines. What I'm going to teach you guys today is the new and improved method for the first time ever. Like I've ever taught anyone this method. And I think you'll be very surprised by how easy it is to actually model terrain realistically if you just know the simple steps that you need to take to get to that point. So in the worksheet that I shared with you all, I had a little paragraph in there, which I call mise en place. Mise en place, if anyone has ever seen cooking shows or heard chefs talk, is this concept of doing your ingredient prep first, all your preparation before any cooking. And I like to use this metaphor as a way to describe how I approach site modeling and how you all should approach it as well, which is you should not rush so quickly to get into the modeling itself, but rather understanding what elements you need to have before you begin to actually model anything. So a lot of the tutorial that we're going to work on as part of this workshop is about that preparation, taking the data that we've been getting, processing it in such a way where it actually becomes useful, say in Rhino or in Infraworks down the road, and then bringing everything together to actually create these realistic models. So the tool that we use primarily for this, I call it ingredient prep, is going to be ArcGIS. So ArcGIS is the starting point. The first program I ever open whenever I have any new project that I work on is like, I go to GIS, I set up my data, and I begin to set that up. And then from there, I take that data and I bring it into a tool like Rhino and then begin to model in 3D first. So we never start modeling before we do any of this preparation work. So all the initial steps that we're going to show in this tutorial today is going to be the ones that they're related to that ingredient prep. So we're going to get into that first. And yeah, so that's pretty much the introduction to the tutorial. Any thoughts or questions before we get rolling on the things I've described? Is everyone excited to see what's going to happen? All right. Okay. So let me share my screen. And also, like, if you download that worksheet, you will see all the steps that I'm going to go through. So you can even just follow along yourself using those steps that I've given, or just follow follow my screen. All right, everyone can see my screen? Yep. Okay. So the first thing we're going to do is we're going to go into ArcGIS Pro, and we're going to set up a new map. So we're going to click on map here, and we're going to give it a name. I'm going to call this one Montgomery tutorial. Oops, can't spell tutorial. And so you could use if you wanted to use your same ArcGIS Pro map that you set up for assignment 1, you can use that as well. But I just want to show the process from start to finish. So literally starting from a brand new document and then moving into the whole modeling process. The first thing that we always do, and as you remember from the initial tutorials, that we always want to make sure that we're working in the correct coordinate system. So what I always do is I go and I double click on the map in the table of contents layer on the side. I go into coordinate systems and I make sure that we're always working in the NAD 1983 coordinate system for whatever site that we are working in. In this case, we're working in Alabama. So I just search for Alabama, and then I can go into the projected coordinate system. I go to the state plane, and then you can go to the NAD 1983, and I always want to choose the feed option. And then because we are working in Montgomery, that's the Alabama East coordinate system. So I click on that and I hit OK. And so now the map has now been scaled and distorted in such a way where it fits. You can see how Alabama now is sort of in the center, and that's what we're going for. So let's zoom into Montgomery. And now let's basically add in all the data that I provided to you in the tutorial folder. The folder, the information is going to be, actually got to connect to that folder first before I do anything. So you connect to the folder that you have saved your data into, and in my case, it's just on in this folder here. It's not quite working for some reason. 1 second. Why is it doing this? Let's just click on it and just be able to connect. No, I feel dumb. It's should just connect. 1 second. I'll cut this part out of the tutorial. Copy that for connection.
But we learn from your mistakes.
Yeah. Am I going crazy here? You should be able to click on the. I just paused the recording. Please tell me I'm not the only one who's dealing with this right now. Just add for a connection. Hit enter. Sorry, as you know, tutorials never work whenever you're doing it live.
I don't know that I can see the issue you're having. What's going on?
Yeah.
Okay, for some reason, I don't know. It worked now. Sorry, guys. Weird detour. I'll cut that part of the tutorial, but that's all we're just doing. We're just kind of in folder. It's like literally the easiest step. All right, continue. Sorry. All right, so once you've connected to the folder, then add the data that is going to be used for this tutorial. So in this particular instance, I have this thing called LiDAR ground 00. So this LiDAR ground 00, it'll take a minute to add because it's pretty big in size. And it represents basically that high-res DEM data set that we were given from the, the county. Sorry, 1 second. And what I did was I basically clipped it to just the River Region Trails Montgomery area, just so that the data is a little bit easier to manage on our folders. So it just takes a second to add. It'll populate in a moment. That's the first data set that we're going to add. And then the second one we're going to add is the River Region Trails framework, just so that we can see where the greenway alignment's going. Okay, so that's added in here. So then also we're gonna add the River Region Trails line. So that's this one right here. And then we're also going to add the little aerial link. So it should be this link here. It's a layer that basically connects to a server and then uploads this high-res aerial image of Montgomery. So this, if you zoom into it and look at it, you'll see that it's actually a super high-res base image of Montgomery. And so this is great because we can use this as essentially a ground texture for the final model that we're going to work in. So this is the starting point of the tutorial, just setting up this basic map here. Then we just save this. Every time we reach a major point, we just save the project so we don't lose our progress. The first thing we're going to do is we need to pick an area. So let's turn the River Region Trails alignment here and let me make the line a little bit easier to see. And make it like blue and make it 2 points. So let's pick an area. So I wanted to maybe, just so we kind of let it be natural and fluid, anyone on the call right now have a suggestion for a site that you're curious about that we can use for this tutorial? I wanted to throw it out to one of you all.
There's a train track just to the right of the center of the spokes of the wheel. You know what I'm saying?
This?
Oh no, it's like where
this?
It's a 5-point intersection.
A 5-point intersection.
It's right by the river.
Right here? Do you see my hand?
No, it's like 5-point intersection of the blue lines. Oh, 4, 5. Yeah, 5. You see it?
Could you be more specific on? Wait.
Yeah, just keep zooming in. It's right on the river, and the 5 of the blue lines come together directly on the river.
Right here, right?
Yeah.
Okay, that's what I
Okay.
thought.
Yeah. So somewhere in the area, like to the right, there's some swampiness and some tracks. I felt like that might be an interesting area. But
So-
if anybody else wants to call it another spot, feel free to.
So this area here. Just be very specific with me. Like, is this what you want? Is this the area that we want to use? Anyone?
Oh, I'm sorry. The blue bay where those intersect.
This?
Yes, right there.
Okay. I don't know if on my screen has a delay to it because I've been looking at this area for several, and you seem to like saying it's somewhere else, but it's this area right here, right?
Right.
Okay. Does it sound like this look like a good area for us to study? Anyone have other suggestions? I was actually hoping that we would choose, say, for instance, an area like here, or an area like here, an area that has or even like an area like here, where there's actually a lot of very dramatic topographical features, because I think it'll just be more of a more dramatic tutorial. Say again?
Go for the drama.
Go for the drama?
The place right to the left where you have that cliff.
Here, this bluff?
Yeah.
Okay. All right, let's do that. That's an area that I thought would be very fun to do as well. Okay, I know I kind of led you on a circle where eventually I just chose the area that I wanted to do, but I was trying to be democratic, but no more democracy. We're going to end this. This is going to be the opposite of that.
Totalitarian regime.
Exactly. Yes. Okay. So for this tutorial, I'm going to do this area here. You can follow along in the same area as well if you want, or if you want to choose another area just for your own purposes, you can. So this is the area that we're going to work in. What I recommend doing for this particular tutorial is if you see the scale bar at the bottom of your map frame right here, you can see my mouse, right? Everyone can see my mouse, so you can follow along. Okay. I was a little confused if you weren't able to see it or not. I recommend working at a bit more of a manageable scale. So in the worksheet, I recommend it's something like 1 to 2000 scale right here, simply because let's just say this, if you went further out like this and try to do a model of this large area here, just think about that in terms of how much processing power and computing power your computer has. The larger the area that you're trying to model, the more time, the more processing power, the more energy you're going to have to use in order to do that. So start small is my recommendation, especially if for all of you who are learning this for the first time. Don't try to get too ambitious too quickly. Start small, then slowly begin to expand your boundary and see what your computer is capable of doing. 1 to 2000, this is several city blocks, but not the entire city. So this is a manageable area that we can model. So let's do something like this, where we get a little bit of the riverfront, we get this bluff area here, we get some of the highway. So this is an interesting area that we can use to model. So once you have an area sort of selected, first thing we do is we don't create a bookmark so we never lose that spot. So I'm gonna create a new bookmark. I'm gonna call this one area 01. That's what I wrote in my tutorial sheet. So that's what you should be able to do. So click area 1. And now if you go anywhere else in the map here, you should be able to go back and go back to area 1. Save your map every time you make one of these steps, just so that we don't lose our position in the thing here. So now we have a map area there. So what we need to do now is philosophically, here's what we're going to do. This DEM image here that you see here, we need to translate this image here into a grid of spot elevations. So we're not translating these into contours, we're translating these into spot elevations. A DEM, and I think I've described this in the past, a DEM file, if you zoom into it real close, you can begin to see like all these little pixels that are on this image here. Each one of these pixels essentially represents a spot elevation. So each one of these pixels represents a number. So you can see if I click on each pixel, the number changes ever so slightly. And that is essentially what a DEM is just a huge grid of pixels where each pixel has a piece of information, which is a spot elevation. So we can directly translate this this DEM here into those spot elevations. So spot elevations is the better translation of the terrain into a piece of information that gives you a higher level of accuracy over contours. Contours, let's say you put a contour and the contour like has a 1 foot spacing. If you think about it, all the space between a contour line is not represented in any way. So there's like always a little bit of a gap between the contour lines, and there's missing information between the two. With spot elevations, you have fewer missing pieces between all the spot elevations. So what you get is a higher resolution result from that process. So go to your bookmark, make sure you have your bookmark set here. And what we're going to do is we're going to go to the geoprocessing toolbar right here on the side. If you don't remember where that is, you can just go to view, and there's a geoprocessing toolbox right here. And we're going to search for a tool called Fishnet. So there's this thing called Create Fishnet. So what Fishnet basically is a tool that allows you to create a rectangular grid. And the rectangular grid gives you two things. Number one, it gives you a series of polygonal boxes, like cells that represent the grid, and also gives you the center point of all the cells as well. And the center point is actually what we're going for. So output feature class, we're gonna give it a name. I'm gonna call it grid 1. And you'll see when you put that name in there, it automatically saves that feature into your geo database for this file, Montgomery_tutorial in my case. All right, then in the next line here, template extent, you're going to want to hit current display extent. See what I did there? I just click on current display extent, and make sure that you have your view set to your bookmark before you do that. Because essentially what it's going to do is going to create a grid of points only in the area that we're seeing in the window here. Also, keep in mind that because it's literally just the map frame that we see here, if, say, for instance, you fudge around the size of the map frame, that affects whatever this ends up being. So you can actually, say, for instance, if you want your grid to be more square, you can fudge the sides of your toolbar. It's kind of a weird thing, but you can do that in order to create a different result. But in this case, I'm just going to go back to what it was before. So again, current display extent, and you see, because I fudged a bit, the numbers changed a little bit.
Hey, Frank.
Yep.
Do you have issues ever, like whenever I do that and then I go back to my bookmark, it sets back, but it doesn't set back to the same scale?
That's a good question. I'm not sure. I mean, in my case, it seems to, you might just like try to make sure that, you know, set a new bookmark, like set your scale to 1 to 3000 and then try saving your bookmark again. I'm not sure. I have to see what's going on your computer, but it should technically maintain the scale. Okay. So leave everything else in this fishnet thing as is, but the thing we want to adjust here is this thing called cell size, width, and height right here. So these numbers here, what that's going to basically determine is the spacing of the grid of points that we're trying to create here. So our map, we set the coordinate system to feet. So whatever number we put in there represents the grid spacing. So if for this tutorial, I'm going to suggest we put 5 in there. And that's essentially what that means is going to be 5 feet spacing in the horizontal direction and 5 feet spacing in the vertical direction in plan view, right? So that's kind of what you use to kind of determine the density of points in this space here. Keep in mind that, you know, if you make this number smaller, say like 1 or 2, that's just going to exponentially increase the number of points in this model that we create here. So don't go overboard with the number here. In general, it's better to go big with this number and then like go backwards and like reduce it slower and slower, as opposed to starting with a really small number and then exploding your computer. 5 is a good place to start, I think. So that's a 5 foot by 5 foot grid. Then everything else you can just leave as is. You don't need to change anything else, but make sure that this box here, create label points, this box is checked, because this is actually the output that we're going to use for this. So hit run. And then when it finishes the process, like you see here, I'm just gonna hit save. Again, continuously save your project as you work through the model. And you can see here, if I zoom out just a little bit, you can see again that this grid of points only created a grid of points in that viewport frame that we created. So we only need the points, this data set here. In this case, it's called grid 01 label. For some reason, the points, they give it the subheading label. So for grid 01, these little polygons, we actually don't need these. So I'm just going to right click on it and remove that. We're only going to work with these points here. Okay, so the next step we're going to do is we need to take all these points here and we need to ask GIS. All right, at this point right here, it sits on this particular spot elevation there. I want you, GIS, to take the number from this spot elevation and this DEM below it and add it to that point right there. So there's a way that GIS can do that. And the tool is called, go back to your geoprocessing window and search for add surface information. And you notice that this tool here requires the use of 3D Analyst. So if you don't have the 3D Analyst extension enabled, then this won't work. So then here's what we do. In input features, this is going to be those points. So it's grid 01 label. Input surface is going to be the LiDAR raster. So in this case, Montgomery LiDAR ground 00. Then output property, it's this. So you check a Z box, the Z right there for this to work. And then you hit run for this to work. One thing I will mention before we hit run is this number right here, Z factor. See how this is just set to 1. In this particular instance, the data that we're working with, this DEM, I know the units of this DEM are in feet, basically meaning that each one of these pixels that we see here, the elevation is already in the feet unit. But a lot of DEMs that you will download from USGS or any other sources typically are in meters. And if that's the case, you're going to want to add a Z factor here to convert the units from meters to feet. And this was the same process, if you remember, when we cut contour lines, of adding that Z factor of 3.28084. But for this particular class and for this particular data set, we just need to set it like this. So now you can just hit run and you'll see that it'll begin to process that data.
By distance, you're referring to elevation, or is the size of the pixel in width and height also equal to 1 foot, or both?
You're talking about the grid of points that we set up in the Fishnet function is in feet. Because the map we set up the coordinate system at the beginning of this project in feet. So it's going to be in feet. Keeping your units straight is always the key to this process. So right click on the point label, go to the attribute table, and you'll see what happened is this. In the attribute table, we have all our points here, and you'll see now there's a Z column right here. So now every single point has a spot elevation associated with it. So now that point knows, if I click on that point, it has a Z value associated with it. Right now, let's zoom in this one here. Like we click on this point, it's 186.7 something. If I click on the cell next to it, it should have a similar number. I'm not sure why it probably interpolated just a little bit around it, but the number is essentially, it picked up the value from the terrain below it and added it to the spot elevation right there. So each of these numbers here is very accurately, almost 100% accurately, a representation of this DEM, and then adding that information into this grid of points here. So we're almost done with this process, but before we do anything else, this is part of the preparation work. If you export this feature to CAD and Rhino, chances are it won't successfully project the points to the right elevation. Like they'll still export this grid of points as like a flat grid of points. What you want to create is a condition where when you export this grid of points into CAD and then bring into Rhino, every one of these points has the correct elevation already built into it. So the way we do that is when you export this out to CAD, you can click on each point individually, one by one, and then manually type in the elevation for each one of these points. So in this case, we have 270,000 points. So you just need to do that 270,000 times. That was a joke. It's my frank humor for the day. No, we're going to do this automatically. You don't have to do that. What you have to do is you click on this button right here in the attribute table, add field. And it brings up this field editor here. So what you do, there's a magical field name called elevation. Elevation, all caps, like so. If you create a field in GIS and you call it elevation, any number that you put in that field is going to be the elevation that that feature exports to. So if this is a contour line or something else, that's what you want to use. And you want to make sure your data type here is set to double. Double bit, all that basically means is just a really precise number with a lot of decimal points. That's all it is. So this is what you need to do. And you hit save. And now you can close this field editor like so. And now you see the elevation on the side has populated in your attribute table. So now what you do is you click on the elevation field. Make sure you don't have any points. By the way, make sure you don't have any points selected as you do this. If you say, for instance, have like a point accidentally selected while you do this, if you do any processing on that particular attribute table, attribute field there, it's only going to process it for that one selected point. So make sure you have none of the points selected first. So then right click on elevation, choose calculate field. Then all you do is just click on Z right here in this fields table right here and just double click on that. And you see how elevation equals Z. And just hit run. Any questions?
Hey, Frank. Oh, sorry, you can go, Lily.
I was just gonna say, Aaron put one in the chat.
Yeah, where did we, I missed the part where you're saying that we clicked on it and then we set it to double for the data value.
Double, so basically double, that's just a name. That's a category of data. We're not actually doubling the data. There's multiple types of data types. There's text, integers, floating values, double values. A double, all that means is basically a number with a lot of decimal places. That's all it is. And all that means is a very precise number. An integer, as we all know, is a number with no decimal places. It's just a whole number. Whole numbers are only precise to the smallest whole number value, which is 1, but you can't get much more precision than that. So that's all it means when I say double. It's just like choose the data type that has the most amount of numerical precision, and that's a double. That's all.
And then, okay, and I think I missed the part. So when you're setting that Z equals 2, so I'm on the same part that you are right now. So you clicked on the elevation.
So, correct. So here's what you do. Like in this field here, you just, when this, I'll just go backwards and do it again. So you right click on imagine that this table here is empty. Right click on that, hit calculate field. And just follow me in real time here. I'm not doing anything. I'm just moving my mouse over Z, clicking on that, then double clicking on it. And you see how that Z just kind of populates in there like so. That's all it is. And then you hit run. This is why having the class recording helps, because you can just follow the workflow in real time. But once that process finishes, you see right here, we have elevation, and there's a number now in the elevation field, and that's equal to whatever that Z number was. We just made a copy of that field, but now it's under the heading elevation. So this data set, if you export this CAD, all the points now project that elevation right there. And you've done it. See, that was easy, right? Like it spent in actual process, if you do this for real, like the whole process that we went through would take you 5 to 10 minutes to do. And that's how easy it is to create realistic, high resolution terrain models. It's not that complicated. You just need to know the steps. But we're not going to do that yet. We still have a few more steps that we need to do before we do any of that first. So next we're going to do is we need to take this grid here. And what we need to do is we need to create a bounding box around this whole data set right here, because we need to have a rectangle that kind of represents the extents of this, because we need to use that rectangle to basically pull an aerial image and use that as a texture. So this is another part of the prep work that we got to do. There is a geoprocessing tool, and it's called minimum bounding geometry. Right there, minimum bounding geometry. So click on that. And then in input features, these are going to be your points. So this grid 01 label, these points right here. And then output feature class, just give it a name. We'll call this one grid 01 B box for bounding box. Then geometry type right here, you want to select this envelope option right here. And all that basically means is it's going to create a bounding box around all the points with a rectangular shape. Then you leave this group option set to all. So this is how it should look like before you hit run. And then you hit run. So if you turn off the points, you'll see now you have a rectangle. And see this rectangle wraps very tightly around the points exactly. So you've created now a bounding box of that area very easily. This bounding box tool can also be used, say for instance, if you want to create a simple bounding rectangle of like other features, not just points. So this is a handy tool for various functions. So the model that we're going to build is going to be of that rectangle right there. What I'm going to do is I'm just going to hit the symbology of that rectangle, and then I'll just make it a very simple black outline so you can see through it. Hit save on your map, save as many times as you need to, so you don't accidentally crash and lose all your work. Okay, now what we're going to do is we're going to turn off the terrain. We're going to turn off the river region trail line. And what we want to do now is we want to take and capture an aerial image within that rectangle we've just created, because we're going to use that as a texture to the base that we're going to work in. So the first thing we need to do is actually, this makes the process of cleaning up the texture easier later, is to clip the model, clip it visually, like create a little mask essentially of just the area within this rectangle. So what you do is you double click on the map in the table of contents toolbar on the side, and then there's this clip layers thing on the side here. And then you can see right here, there's an option to basically clip to the outline of features. So click on that. Then we're going to choose the bounding box as the clipping box. Hit apply, click OK, and you see what happens is that it's essentially acting as a mask. So it doesn't actually clip the data, it just masks out any data that's outside of that box. So turn off all the layers in your table of contents except for the image. So the image that you see here, the high-res image, this is what we're going to export out as an image file. So what we're going to do first is we're going to create a new layout. So go to the Insert tab at the top of the ribbon. There's a new layout button right there. So click on New Layout. And you have all these options for layouts. You can create your own custom page size. What I do for this tutorial is I just literally pick the biggest page size that's given to me. But obviously you can choose to make it bigger if you need to. The biggest page size is going to be the 36 by 48 ArcGIS size right here. So I click on that. We're going to click on the landscape one because our thing is in landscape. And then you see that there's nothing in this layout here. So you need to click on this map frame button at the top of the ribbon right here, map frame. And then you just click on the area_01 bookmark that we created. So click on that. Then you just like click and drag that area. And you can see how my map frame, I make it actually a little bit bigger than the page size itself. Just so that I can make sure that if I want it to be full bleed, I can. But in this particular instance, what we need to do is we need to click on the map frame, go to the layout tab at the top of the ribbon, then click on this activate map frame button. And that allows you to now like rescale and move everything around. So you see now I can like actually dynamically change the scale of this here. What we want to do is this, is we want to position this image in such a way where it almost fills the entire page. You can see the white representing the paper. We want to make sure it fills it out as much as we can, but we also want to make sure there's a little bit of a margin all around it. And I'll explain why in a second. So you want to do something like that. You can see how like I literally maxed it as much as I can, but there's still a little bit of a white margin around the whole page, like so. Then once you've done something like that, you go to the Activate a Map Frame tab at the top of the ribbon, and you click Close Activation. And now you don't have to worry about moving it around again. Now this, if you set this up, hit save also so that we don't lose that. This here, we now export out. So you choose the Share tab at the top of the ribbon, and you click the green arrow that says Export Layout. So click on that. And then it's going to ask to save it as what file type. So PNG is what we want to use, PNG, because what that does is allows us to have a transparent background. So everything that's white is going to be transparent in the export. And set it to a 300 DPI resolution, then save it somewhere. So we're just going to save it on the desktop. And then I'm going to call it, what did I call it in the sheet? Call it area 1 aerial. Save. And then once you've set that up, then hit the export button at the bottom right. So hit export. And this will take about a minute to export. So while they're exporting, is there any questions from the class?
Whenever I try to do the add service information geoprocessing tool, it's telling me that mine's not my tool isn't licensed.
So you're going to need to make sure you're logged in to your account.
Yeah, I am.
And then you're going to need to make sure that your extensions are enabled. And that should have been something that was taken care of at the assignment 1 phase, ideally.
Yeah, that's. I don't know why it's doing that.
Is anyone else not able to get the 3D Analyst extension? Or Dan, are you the only one?
Yeah, it let me do the Fishnet thing, but then I do add service information and it pulls up and I click on it and it says tool is not licensed.
Okay. That's a question we'll need to I might on Studio or on Friday, I might need to take a look at your settings, but you should just basically be logged in. If you're logged in, you should be able to observe and look at, double check to make sure you have your licenses activated. So number one, make sure you're logged in up here. Number two, if you go into the side here project and then go to licensing, you should ideally see licensed have a yes next to it. And
Mine
that's
say no.
okay. So that's an issue. So we need to talk to Steve Wall about that because he should have done that for everybody. So I'll send him an email, make sure that you get added.
Okay, cool.
Yeah. As I said, this export takes a bit of a minute, so it's still going in the background. So we're just kind of hanging out until it exports. Oh, there it is. It just finished right now. Okay. So once that finishes exporting, we can go find that file on our desktop somewhere. So I saved it right here. Area 01 area. A lot of area in the name. So what we want to do is we want to open Photoshop because we need to do some quick editing to that image right there. This is part of the prep work, like I mentioned, in terms of getting all our files set up. So in Photoshop, and then we hit open, and then we find that PNG we just created. And then what we do is, what you want to do is you want to basically clip out all of the transparent pixels in this image here. So the tool for that is this trim button right here in the image menu at the top. Then trim transparent pixels. So click OK. At the reason why it doesn't trim it at the bottom is because if you zoom in here, like there's this little like text thing right here that's kind of like preventing it from trimming successfully. So you just need to click your crop and just like remove it like that, and then trim it again, trim transparent pixels. And then that should successfully do it. You don't want to crop it like manually because you actually want as close as possible this dimension to be exactly the dimension of the bounding box rectangle that we created in here, right? The grid B box. So using the trim tool in Photoshop just ensures that you're not accidentally like taking away a pixel or adding another pixel. It's just a lot more precise. If you zoom into this image here, you'll see that the results of this export is a really nice high resolution base. You can see there's a lot of good detail in this image, as you can see here. So this is as good as, say, for instance, a drone aerial that we might capture manually. I was really happy that I was able to find this aerial for our studio because now you're going to be able to basically have a high res detailed texture that you can apply to your terrain mesh. But one thing you will want to like do is you can see how this image here is just really brown and really yucky looking and just brown, like it's just missing a lot of color. So this is where your Photoshop adjustments come in handy. So just like click on auto tone and auto contrast, auto color, and you can just begin to remove some of that brown, adjust the exposure a little bit. So that's a little bit lighter. I like to adjust the saturation a bit just to give it a bit more vibrancy to it. So this is where you can just go back and just edit this image as if you're editing a base image. I think, but in general, what you want to go for is something that, in my opinion, is just not as, brown and nasty, because you want your models to be nice and vibrant and cool looking. But, once you're happy with the basic look of this, you just want to save it as a JPEG. So I'm going to quick export as JPEG right here. You can also do save as. I'll call this aerial 01 JPEG. Save. So that exports that as a JPEG, and then just save it, save the original PNG as well. So just hit save. That takes a minute to do. But if I go to this desktop here, you'll see basically we should have, yeah, aerial 01 aerial JPEG. And this is what we're going to use as a texture. You could use a PNG as well. I think a JPEG is just a little bit of a smaller file size. And so it's just a little bit easier to work with instead of a PNG, just because a PNG tends to be a little bit bigger. Whoops. Cat infiltration. Get rid of the cat. Okay. So we're almost ready to model our things. We just need to do one last step, which is to export the data from GIS into CAD. What I'm going to do first is I'm going to actually turn off the clipping of the outer bounding box. So I'm just going to go back to the map properties like here. Double click on that. Clip layers is the menu option. And then just click no clipping and then click OK. And that removes all that clipping stuff. And we're going to export the bounding box that you see here. And we're going to export the points as well. You can also export the River Vision Trails framework if you want, but for this tutorial, I'm just going to export these two things. So go to your geoprocessing window here, search for export to CAD, click on the export to CAD tool. In input features right here, you can just click on this little arrow right here and then check grid 01 B box, grid 01 label, and choose add, and then that adds those elements to your export. In output type, just leave it. It should just default to DWG version 2018. That works great. Just leave it as is. In output file, you're going to save that to a location you can easily find. Usually that means your desktop. So I just click on desktop, then just give it a name, call it grid 01 export. Hit save. So now that saves it to your desktop. Then before you do anything else, you want to go to the environments button right here. And output coordinate system, you want to set that to be the current map. And you can see it automatically autofills that to be the Alabama East feet. The feet is the key. We want to make sure the output is in feet, and that doing this ensures that it always does so. Processing extent, I think I talked about this in a previous tutorial. This, whether you set that to be current display extent or not, just purely depends on what data you're exporting. In this particular instance here, all the data I'm exporting, I see right in front of me right here. I know that it starts and ends within this box right here. If your data, for instance, extends beyond the frame and goes to the citywide scale and goes bigger than that, you might want to check this to be current display extent, because then it doesn't export everything that exists within data set. So this just depends on what you're exporting. This particular instance, since we know what we're exporting, we just leave that as is, then hit run. And that'll take a good couple seconds to export.
Hey, Frank,
Yep.
did you say if there's anything that we put in seed file?
No. So it's just about finished exporting. So right now it finished exporting. What I always do whenever there's a CAD export is I just always remove all the layers that get automatically added, because we don't actually need to use them in GIS at all. So the easiest way for me to remove them is I click on this list by data source option in the table of contents, this little thing that looks like a cylinder. And you see that basically it organizes all the data in the map by the location. In this case, all the data from the export comes from the desktop right here. So all these layers right here, these are all the layers that came from the CAD export. So I'm just gonna select them all, hit delete, and that just removes them. We don't need them in GIS. So once that's done, just hit save on the map. And we're ready to go into Rhino. So you all ready for the fun part? All right, this is it. We've done everything we've done up to this point. This has been what I call the preparation, the ingredient prep, the mise en place. You have to do all this work in order to set up your model. So if that's all good to go, let's go to Rhino. So I have Rhino open on the side here. The first thing I always do, actually, before I do anything, I'm gonna open it up to the class because this is something that I've been curious about. Oh, I see, Anna, your export CAD failed. Yeah, that's something that we're gonna have to look at. On Studio on Friday, or maybe let's do this, is that I'm happy to help you all one-on-one, like off hours, and see if we can sort through some of these issues. But before I get into this Rhino portion right here, I was just curious, and I want to open up to everyone. What have you learned to date in terms of modeling in Rhino?
We've done some basic geometry stuff, and then Emily showed us some surface like contour modeling, but I don't think I really remember that, and I couldn't really figure it out afterwards.
Yeah, the like original method was kind of, you take contours, make almost like a pancake model from them, like layered, and then a like mesh of some sort over that. Was about as sophisticated as we got in Rhino.
In MLA2, we did that, but Tom also had us do stuff with Grasshopper also.
Do we need Grasshopper for today?
I'm going to show a method that uses Grasshopper. But Grasshopper should be automatically installed in Rhino 7. Any other comments in terms of, or is that those comments that we just got kind of a good summary of your skill set up to this point? Okay.
Learned a little bit about how to like use Rhino the same way you use CAD to draw.
Okay, so some drafting. Okay. Okay. So on a scale of 1 to 10, maybe throw into the chat for all of you on a scale of 1 to 10. Let's keep it simple. On a scale of 1 to 5, scale of 1 to 5, 5 being I'm a master, 1 being I've opened Rhino 1 time in my life. Where would you say you are? On 2s. 3. Well, City has a 3.2. So far, the star of the studio is 3.2. Okay. 2.9. Okay. All right. Great. So mediocre to below average is my sense here. Mediocre to below average. Okay. Good to know, because when I, that tells me that I have to teach more than teach less in terms of stuff. Okay, that's what I wanted to get as a survey. All right, back to it. So Rhino's open now, and this is how I like to organize my Rhino space, with the command line at the top, all the tools at the just below the command line on the side here. Everyone, you're able to customize your Rhino workspace however you like. One thing I like to do personally, and this is a technique you can use as well, is if you hit the middle mouse button on the workspace here, it brings up this little like mini toolbar here, and I like to copy very commonly used tools into this little thing here. So let's say, for instance, you like to create a lot of rectangles right here. Say, for instance, this is the box rectangle. What you can do is you can hold the control key on your keyboard. And you see copy link, you can drag that into your little thing right there. So what that means is basically if you're in Rhino, if you want to create a box, click that. Much faster than having to find that tool or even type it in. This is, in my opinion, the fastest way to maximize your workflow, is to use the middle mouse button right here as your little fun little toolkit, like kind of like your side, the kit that you when you do work outside, you have a little toolkit on your belt. All your most commonly used tools are right here. And I like this bit method because it doesn't require you to take your hand off the mouse and bring up the keyboard and type in the tool into the command line. Like the least amount of energy it takes to navigate the window is better. So box, plane, and you can easily begin to, model things much faster if you have all your most commonly tools, circle, just at your fingertips as you go. So that's my number one recommendation to master Rhino, is to, find the tools you really like to use and put them into your little middle mouse click thing right there. Okay, now what we do first before we do anything else is you type in units into the command line right here. And we just want to make sure that in the document properties here, that the model units are in feet. We always want to make sure your units are set before you do anything else in the program. We only use feet. That's the only unit that we use for modeling anything. You only need to change it to meters if you're working internationally. You only need to change it to inches if you're modeling furniture. But for everything else that we do in site design, use feet. So once it's set to feet, you type in import into the command line, and then you find the CAD export that we just made. So this is grid 01 export, then hit open. And that's going to import that into Rhino. Before that happens, this little import options thing comes up. Generally, just leave this as is. The most important thing is you want to make sure that model units here is set to feet and layout units here are set to inches. Model units is more important, but this is the most important thing, is just set that to feet. And then everything else just basically leave as is. I never click any of these boxes or check anything else. I just leave it as is, and then I just click OK. And just give it a second to import. You can see that it's thinking about it. Then you see the layers populate on the side here on the right. Now, I haven't clicked anything yet. I'm going to move my mouse over to this button right here, zoom selected. And I'm going to click zoom selected. And then basically anything that you ever import into Rhino is automatically selected the minute it imports. And so just hit zoom selected, and that brings you over to the area that it imports to. This model here is geo-referenced. What that basically means is that this model is located in the correct coordinate system space that matches and links to the GIS file in here. So if, for instance, and I'll just show this demo, this was part of my tutorial last time. If, say, for instance, you draw like something in here, export that to CAD, and then bring that into GIS, it will come in the correct location because of that. But generally speaking, whenever we're modeling things in Rhino, we always want to make sure that we model as close to the model origin space as possible, the 0, 0, 0 coordinate system. And the fact that it's geo-referenced is both good and bad. It's good because it has the correct location geospatially, but it's bad because it's so far from the origin that it can cause instability when you actually model stuff. So what I always do is this is my best practice, is that I create, actually before we do anything else, one thing you could do, there's a very handy tool in GIS, it's called Purge, not GS, Rhino, Purge. If I type in Purge in the command line, you can use this to quickly kill anything like layers or line types or materials or things that are not used by anything in the model. So right here, layers is set to yes right here. So if I hit enter, see all these layers that they don't use just suddenly automatically delete. So that's a quick way to clean up your file. I'm gonna create a new layer now. I'm gonna call this one origin. Origin. You notice how when I write my layer, I put a little hyphen or an underscore right before that. And the reason I do that is because if I sort the layers by name, the underscore automatically shoots to the top. So anything that is like an important layer that I want to like organize and shoot to the top of the list, I always put an underscore next to that. Conversely, if there's a layer that I don't want to look at and I want to put at the bottom, I put a Z in front of it. So the Z junk layer, if you have a junk layer. And so that way, when you sort your layers, you have the most important layers at the top and the layers that you really don't give a shit about. Sorry, language. The layers you really don't care about. I'm a professional. I shouldn't curse, but people curse all the time in the industry. This will get edited out. Is anything you don't care about, you put at the bottom Z. Okay, so this is just a good best practice. So I'm going to set the origin layer, make it red. Set that to be the current layer by double clicking on it. Then what you're going to do is you're going to create a point at the bottom right of the bounding box right here, like so. So this origin point here, this is going to be our key to moving the model back and forth between the origin and then back to its geolocation. So once you set that point there, make a different layer, the current layer, and then lock that origin point layer. So you can never select it. You can never adjust it. It always stays in that spot there. This point, you never unlock. Origin never gets unlocked. You just leave it stuck there forever. And now what you can do is you can select everything in this model, hit M on your keyboard. So you can move all this at once, and then you move it from that origin point right there. So click there, your starting point. And then type in 0, 0, 0, and hit enter. And so what we've done is we take this entire model and we move it from that point to the origin point. But you see how that origin point stays right where it is? Then you can click on zoom selected and you see right now your model has now moved right to the center. This is the 0 point usually has this little grid thing at that point there. So now your model is in a location where it will model perfectly fine. But if you want to go back, all you need to do is you take this model and you move it back to that point over there. So this is a very good workflow to make sure that your workflow is nice and clean, right? Origin, keep it locked. You can turn it off if you don't want to look at it anymore. So now we're ready to go. And you can see if I zoom into this, look at all that. These are all the spot elevations for this particular section of Montgomery. You can see like we've managed to preserve all the topography, all the detail. You can even see things like little imperfections in the terrain. You can see things all over. This is why we use spot elevations as opposed to contours. It's because you get everything. You have very little reduction in the overall quality of the data as compared to contour lines. This is as good as saying, as like, for instance, using the DEM in GIS. It basically is a DEM if you think about it. So what we're gonna do is this now. I'm gonna turn off all the layers except for the grid label layer right here, which has the points. There's two methods. There's two methods you can use. There's one method that utilizes Grasshopper, and then one method that just is a quick and easy way. So we're gonna do the quick and easy way first. And what you do is you right click on the label right here, choose select objects. So that selects all the points in the points. Then you type in mesh patch and hit enter. It's going to say select holes. There are no holes. Just hit enter again. And a mesh just formed around these points. So what I'm going to do now, what I should have done is I should have created a new layer, but we'll just do it now. Create a new layer, call it mesh, then select that mesh, then change it to that layer. So right click on mesh, then click change object layer. So that automatically moves that mesh to this mesh layer right here. So set that mesh layer to be a current layer, turn off your points, then go to, say, for instance, a rendered view. The way you do that is just like right click on the blue thing, the upper left of it. You can see all these view styles right here. Rendered is one, shaded is one as well. You can also set your own custom ones. I set up like my own custom one called shaded texture. This is the result that we're going for. We're going for basically this kind of terrain model. You can see how much it looks pretty much exactly like the data that we've exported out of GIS. You can even see all the little imperfections again in the terrain. And this is why we use this method, is because it allows you to translate DEM data into a terrain mesh with very little reduction in quality. And this is how you get high resolution, accurate models of the data that you've collected. And everything is still at the correct scale and the correct dimensions. So if you get to this point here, you've already achieved more successful terrain modeling than virtually 99% of architecture students, landscape architecture students, urban design students in the entire country. So with that, I'm going to pause for questions if there's anyone who has questions about how to get to this point.
I have one, Frank. I was just wondering how you would get back to the origin if you wanted to take the model back to your origin point. Like, what are there coordinates for that, or you just drag it back to a layer, or what?
Good question. So let's say you want to take this, it could be that any information. What you do is make sure you have the origin like turned on over there. You can see that point over there. What I recommend doing is, like, say, for instance, go into a top view. Let's turn off the mesh for now. You just got to remember that you're moving it from the 0, 0, 0 point. So hit M. So it's basically the same process, but going backwards. So type in 0, 0, 0, right? So now it's moving it from that origin point, and then just zoom out, and then you just find that point. It's right over there, right? And then just like snap to it. That's it.
Cool, thank you.
That's all it is. You can also like get the coordinates at that point and then like manually type it in. But usually, like, that number, that coordinate number is like just a huge, big number with a bunch of decimal points. And it's probably more of a pain to remember it than just to do what I just did, which is just move it manually. So it's just the same process, but backwards. So anyway, back to the mesh. Again, this is the result that we're going for. This you can process and you can throw into a 3D printer. This you can process and you can throw into a CNC machine. Like, this is how you actually like build really high quality, accurate terrain models for your sites. And again, we're just dealing with a small little chunk here. And, depending on how powerful your computer is, you can scale it up, you can scale it down. You can increase if you remember the cell size between the points, you can increase the spacing of it to get even higher quality mesh if you want. But as you can see here, like, it's pretty detailed already. You don't need to get any more detailed than this. So I wouldn't recommend going any more detailed than a 5-foot spacing personally. The next thing you should do, so there's two methods. There's creating the mesh and there's creating the surface. If I click on the mesh here, you'll see that if I zoom into it, there's just like a lot of these grid cells, right? That's good, but it's also poorly optimized. And optimization is something that you're just going to need to learn how to do. You're going to always want to make sure that data you're working with is always simple, not too complicated, not too dense in detail to the point where it's unusable. So there's a function in Rhino called reduce mesh. So I click on that mesh, and I type in reduce mesh. See, it automatically finds it right there. Click on reduce mesh, and it brings up this little thing here where it allows you to reduce it. Right now, this is a mesh with a 500-something thousand polygon count. So what I do is I click on this thing here called reduce by percentage, and just play around with that number there. Let's say you want to reduce it by 70%, which is, believe it or not, will retain a lot of detail, but you can see like the number of polygons is cut down significantly, right? Click OK on that. It's gonna, you can see right here in the command lines, reducing that mesh by, it was slowly processing it and then reducing it. But once it finishes, you'll see what happens. Optimization is an underrated, underappreciated 3D modeling skill. So there you go. You see what happened is like in some areas, like for instance, this river area, which was generally flat, had 1 million cells. It's basically simplified it in such a way where it doesn't have 1 million, well, several 100,000 cells. In other areas where the terrain, you know, like say for instance, the road surface didn't have that much detail, it just simplified it in such a way where it doesn't have as many cells. But you can see if I unclick it, it almost looks exactly the same. You couldn't tell the difference visually between this and the previous one. So optimization of your cell is important. It reduces file size, it reduces the speed at which it renders. Everything is better when you optimize the model. So that's a very handy thing to do before you do anything else. Another thing you can do is cut contours from this. So you notice how, like, you know, you can cut contours in GIS the old-fashioned way, but this method of using spot elevations here to bring this mesh here is, like I mentioned, almost as accurate, if not as accurate, as if you were to cut contours from a DEM. So you can cut contours from this mesh here and get really good contours. So click on the mesh, type in, actually, before you do that, create a new layer, call it contour. Set that to be the current layer, right? Then click on the mesh, type in contour. Base point, you're gonna wanna click on some point at the origin. Like everything along this box at the bottom is already at the 0 elevation. So you always wanna like click a starting point at the 0 elevation, like so. And then go into like a front or right view right here. You see how front on the bottom left of the screen, there's this front or right view. You can use that to basically create a vertical projection line in the vertical direction like so. So I'm just gonna hold shift on my keyboard, and then you're basically locked in a vertical direction. And so just make a vertical line, then click, and then distance between contours is at the 10 right now. You can maybe set it to 5 or a 5-foot contour. Hit enter, and you see you create these lines. Then the perspective view, you have your contour lines. And you can see that these contour lines, you can even see in it things like the road crowning, everything into it. It's a pretty good way to get contours. Maybe you want, let's undo that. Maybe you want 1-foot contours. So click on the mesh.
Frank?
Yep.
Oh, wait, are you doing it again?
I'm doing it again. I'll do it one more time.
Okay, sweet, thanks.
Yep. One more time. So you click on the mesh, make sure you have contour, new layer in here, and make that set to your current layer. Then type in contour into your command line. It says asks for a contour plane base point. You always want to make sure that your base point is anywhere along the 0 elevation. You see how this blue box here is projected to this grid here. This blue box at the bottom here, that is already all on the 0 elevation. So you can literally click anywhere, say for instance on that line there, and you know you are set to a 0 elevation. But you see how like this line here doesn't want to like create a vector that's a vertical. An easy way to make sure that the force had to be a vertical line is to go into a front or a right view down here. So go to like front. Now you see you can now set a vector in a vertical direction. So I hold shift on my keyboard, and that forces the line to always be in a vertical direction. So I hold shift, then I click, and then it's asking for the distance between contours. Right now it's set to 5. If I hit 1, you can set it to a 1-foot contour. So now you hit 1 and then enter, and then you see it just slices contours at 1-foot intervals. And then you can go back into your 3D view here, and you get your nice little contour plane right here. You can see how that is a very nicely detailed contour plan. You can almost say that this method is almost easier to do than to cut contours from GIS. But I'll say that the method here is as accurate as cutting from GIS, because again, we're cutting contours from essentially this information right here, these spot elevations, and these spot elevations were derived from the DEM, which is the raw data. So again, we're not reducing the data's resolution in any significant way through this method. It's pretty cool, right? No?
Yes.
Good. Very-
Crazy easier than what we've done in the past.
Yeah. Like I said, no one in any architecture school or landscape architecture school is learning this method because everyone is stuck in pancake model world. You should feel lucky that you're learning this. Like no one teaches this. Let's just put it that way. And one of the unique things about landscape architecture, and wait, oh, one second. Oh, shit. All right, sorry. The cat just jumped. I was like, that's why I was like waiting, is because like the cat was like ready to pounce on top of my desk, and I just had to. Yes, Alex. Yes, good. It's a Zoolander reference. It's a great movie. The sequel is terrible though. Oh my god! Like the first Zoolander was really great, and then the sequel like was literally one of the worst movies ever made. I can't believe it. They really bombed it. So what was I going with this? Okay, so landscape architecture. This is just me kind of going on a rant here. Is a unique profession because it combines site design, natural systems, planting, cartography, GIS, with things like this, like 3D rendering, 3D modeling, visualization. Like landscape architecture is one of those unique professions where it brings all these multidisciplinary skills together. And so our profession is uniquely positioned to do this kind of stuff. Not many other professions has that wide-ranging skill set where you have all these tools at your fingertips and you can do these kind of cool things. So that's one of the opportunities that I hope landscape architects, as they move along and grow this profession, is that we begin to really think about how we utilize our unique skill sets to maximize and push design forward. Architects aren't even doing this because architects don't know how to use GIS, right? All they know how to do is like use Revit, but landscape architects can use Revit too. So you can see like how like, you know, our skill, our profession is one of the more unique ones to have all these skill sets. Let me do some work. Sorry. The cat is like causing chaos behind in the background. Chaos cat. All right. Any questions? Hopefully this is fun. Do we need to take a break or should we continue? Break? Here's what we'll do. Let's take a break at 3, just because it's kind of like a 2-hour mark between the halfway point of the semester, halfway point of the workshop. So we can, there's actually a few more things that I want to show you first with this, and let's take a break at 3 p.m. so you can get some water or go to the bathroom or whatever. Okay, so what we're gonna do now, we're gonna show you the other method. So what we created first was a mesh, right? Let me turn off these points here. This is one type of surface that you can create in Rhino. The other type of surface is literally called a surface. So there's 2 types of geometries, meshes and surfaces. Meshes are kind of like your basic, rudimentary, really simple piece of geometry, but literally all this is just like a bunch of polygonal cells just kind of like stitched together. That's all it is. A surface is like a mathematical representation of surfaces, and a surface is a lot more intelligent than a mesh is. And one way that you can think of that is like a surface, even if you trim it, even if you cut it, it still remembers what it was before it got trimmed or cut. So a surface is a little bit more of a useful thing to model in while you're in Rhino. So here's how you model surfaces. And you're going to enjoy this method because it's so unintuitive that you'll wonder why it was never taught. So what we're going to do is we're going to start with this B box right here. I'm going to make it a red color so it's easier to see. What I'm going to do is I'm going to open a notepad on the side. And I'm also going to open a calculator on the side. And you would use this, maybe just use like a pencil and paper or something like that on the side. But I'm going to just have these on the side. All right. So I'm going to go to Analyze in the top menu here, Distance. And I'm going to measure the distance of one side of this rectangle. And I get 3270 feet, 3,270. So what we do is we do 3,270, and we divide that by the, if you remember when we did the cell sizes in GIS, we did a 5-foot spacing. You divide that by 5. So we get a number, 654. Then you take 654, then you add 1 to it. So we get 655. The cat's causing chaos in the background. I have to make sure she's on it because she's going to jump on top of the computer and like mess up everything. Sorry. 655. So I'm going to write in my little notepad here, 655. And then you're going to measure the other direction here. So go Analyze, Distance, click, click, 2,060 feet. 2,060 divided by the cell size, which is 5, 412. You add 1 to that. So we get 413. I just need to remember these numbers. So I just wrote those down on the side. That's it. Okay, now go ahead. Is there a question?
Why are we adding 1?
I will explain in a second. Just
Okay.
believe me, trust me. What we do now is we open Grasshopper. This is where Grasshopper comes into play. This is why this method is not as intuitive as the other one. So to open Grasshopper, you either click on the little green button right here that says Launch Grasshopper, or you can just type in Grasshopper into the command line. So open Grasshopper. I think Mimi is hungry. That's why she's getting causing chaos. She's wanting me to like stand. So at 3 p.m. I'm going to feed Mimi and she'll settle down. So this is what Grasshopper looks like, right? Who here is, I'm curious, who here is going to be in Graphic Studies 3 next semester? Is it the MLA third years or the second years, or is it all of you?
Maybe all of us.
Maybe all of us. That's
Third
my
years haven't taken Graphic Studies 3, so I'm assuming we'll take it in the spring.
Okay. Anyway, for Graphic Studies 3, that's one of my plans is to like really dive into Grasshopper more because it's a fun opportunity to like learn this tool. And it's kind of like it's like a fun thing to learn before you graduate. So it's not like super important, but I don't want this to be a Grasshopper studio. Let's just put it that way. But for this particular thing, we're gonna use Grasshopper. So what you're gonna do is you're going to choose this little point thing here. So you're writing down the parameters, click on point. And this allows you to bring in the point data. So with that brought in, I'm going to zoom in closer so you can see it. You right click on that thing, click set multiple points. And then what you do is you turn on those points here. You right click on that layer, choose select objects. Then hit enter. Then what you've just basically done is, at least I should have done that. Let me see if it worked. I don't think it worked. Let me try one more time. In this particular case, let me do this. Let me right click the points first, select objects. So now the points are selected. Then right click on this and hit set multiple points. And then it should, yeah, there we go. You'll know it's selected when it like turns red and how it has all these little red little X's on it. So you set those points in Grasshopper. So turn that off. You can see that all these points now exist within Grasshopper. I select on the thing here, it turns green, all right? There is a tool in Grasshopper called Surface from points. Surface from points. So I just click, double click anywhere in Grasshopper, then you can search for the tool in there, surface from points, like so. So what you do, you take this point data set right here. And also, wait, before I do anything else, anytime you use Grasshopper, you have to save your model, save as. So I'm going to save my model on my desktop and I'll call it just area 01 Rhino. Okay, because Grasshopper sometimes crashes. All right, so I saved my Rhino file. Now take this point component here, and then you choose you do the little click and drag to bring the line. Then you connect that to the P here. This is the point data set for this. So you connect to the P, right? So, and then the U number right here, this number right there, you want to click on a panel. So right here in the top, there's this little thing called panel. Click on that. And then go back to these numbers right here. One of these numbers is the one that's going to work. Sometimes, for me, sometimes it's a bit random. Sometimes it's this one, sometimes it's this one. Start with the smaller one. I take that number, I copy it. I double click in there and I paste that in there, right? Then you connect that to U. And that worked. So I got it right the first time. If it doesn't work for you, try the other number. So now you can turn off the point visualization. You see you've created a surface like so. So now this thing here in Rhino, create a new layer, call it surface, make that the current layer. Then we can do is just click on the surface. You can either bake it in two ways. You can right click on the S, then click on bake. Let's just do that. Just right click on the S, click bake. Then click surface right here and then click OK. Give that a second to bake. And then what you do is you click on this little button right here. Don't draw any preview geometry. That basically hides all this stuff right here. Then you can like minimize this right here. And you've created a surface. Two different types of data. A surface or a mesh. Mesh. Yep, there's a question.
Yes, in the previous route that you just showed us, just solely through Rhino and not going through Grasshopper, was that just creating a mesh? You hadn't created a surface in that, had you?
Correct. There isn't, as far as I'm aware, and I can always make sure I'm not going crazy, there is no way to create a surface in Rhino without using Grasshopper. I could be wrong on that. There is a tool called Patch that sometimes students like to use to create surfaces, but that tool is an absolute garbage tool in my opinion, and creates really inaccurate, fluffy, non-useful surfaces. I really don't support the use of the Patch tool. So this method I'm showing right here is how you can create a surface with a high level of accuracy, and it requires some Grasshopper. But here's the thing, like this Grasshopper script that I wrote right here is literally the simplest Grasshopper script of all time. It's not even a Grasshopper script. It's just literally using this one little component right here to accomplish this task. Okay, now to finally answer the question that Farrell brought up, why did I go through all this trouble to do all this math here, add one and all that stuff? And here's the basic, simplest description why of what's going on here. Let me just do a quick diagram and I'll just create some points on the side of the. Okay. So it's a little hard to see, but you can see like, I've essentially created a grid of points right here, and that there actually would be a point in the middle right here. So if you created a grid of points and you divided one side by 2 and the other side by 2, right? So you have like 2 cells, see 1, 2, 1, 2. you have to add 1 because they're actually, the end result is actually 3 points, regardless of whatever the cell dimension is. So if you divide it by 2 and 3, right? 1, 2, 1, 2, 3, you see that the number of points in each direction is actually 1, 2, 3, 1, 2, 3, 4. So we add 1 to account for that extra point that gets added when we divide the sides of the cell. And we have to divide the length and width of a box by 5, because in GIS, when we created this grid here, we created a grid of 5 by 5 right here. So we take that length, divide it by 5, and you get the number of cells on one side. Then you have to add 1 to actually get the actual number of points on one side. Even if you don't understand what I just described, if you just do what I tell you to do, it will work. So sometimes sometimes it's good to understand why things happen. Sometimes you just say, I don't know why it happens, but I'm just going to listen to Frank. And if I just listen to Frank, I know it works. And sometimes that's all you need to know, right? That's what faith is all about, right? That's why people believe in things. We don't know why we believe in them. We just believe, and that makes us feel good inside, right? Believe in Frank. That's the lesson. So it's 2:40 p.m. I said we take a break at 3. Let's take a break now. Let's get back here at 3 p.m. And then I'll finish the tutorial in terms of showing how you can take this mesh here and apply a texture to it. So we'll do that at 3. If you want to try it yourself, all the instructions are already written on the worksheet there. Let's take a break here. Let me write in the screen here. Meet back at 3. Okay. Yeah. All right, so we're gonna wrap up. Let me share my screen again. And we're back here. So this is where we left off before we took a break. Everyone can see the screen, right? Everyone can hear me. Good. So we're going to do the last major step, which is to take this terrain surface here and the terrain mesh, and we're going to put a texture on top of it. And so that's why we did that little image Photoshop thing earlier, is so that we can set it up for that step right here. So what I'm going to do is I'm going to create a new layer. I'm going to call it aerial. Set that to be the current layer in there. And then there is a picture plane tool in Rhino, which allows you to create a surface using the dimensions of any image that you have saved on your desktop. So you just get to it by typing in picture into the command line, hit enter, and then you just find that JPEG. Remember that JPEG we made earlier, area 01 area underscore JPEG. You just choose that, hit open, and then it lets you basically draw a rectangle to the dimensions of that. So you start at the bottom left of the bounding box. Remember, this picture is scaled to the right, the exact ratio of that bounding box. You just click on the bottom left, and then you click to the bottom right or the upper right of the bounding box. And now you see we've created a little plane that has that texture image right below the mesh. And so all that work we did in terms of creating this little bounding box in Rhino or in GIS, creating that layout view and setting it up in such a way where it exported out with the ability to trim out those transparent pixels. We were trying to achieve this, which is a precise positioning of this texture aligned with that mesh. So you almost don't have to do any guesswork. It should line up perfectly with it. So the way you apply a texture to any surface or mesh based on like a picture plane like this is you click on the mesh that you want to put the texture on. So it's clicked. You go to the properties tab here on the right. There's this button here called material. Click on that. And right now it's showing the material properties for this mesh here, which is basically no properties. There's nothing here. You can click on this button right here called match. So click match. And then you can choose any object in Rhino that this object here inherits the material of. So we're going to click the picture plane below it. Now the mesh above inherits the material of the image below it. Now you see, it looks like nothing has happened. In fact, it looks even weirder than before. There's one step we have to do, which we have to apply a texture mapping, a texture map logic to this. And all that basically means is that we need to tell Rhino, I want this texture map to basically be a vertical projection using that rectangle below it. So just follow me here. Just click on the mesh. In the properties panel here, there's this thing right next to the material called texture mapping. So click on the texture mapping thing right there, the button. Click on this thing called apply planar mapping. There's all these mapping logics you can choose, but the one that we're going to use is planar mapping. So click on that. And then what you do is you draw again a box of the same ratio and size of that rectangle that we just drew. So we start at the bottom left, and you go to the top right. And then you see up here, it says UV, UVW, just hit UV. And that's it. And now you can turn off in the layers panel the aerial base, turn off the B box, and you've now created a model of that area with a picture. And you can see this picture is really nice and sharp, nice and high res, and it drapes it on top of the mesh. So that is how, very simply, you create a model. And you can see, like the roads and everything, they match the terrain really nicely. If I turn on the contour lines, you can now begin to see how the contour lines actually work with the existing surface in such a way. So now those road crowns, you can see how they actually work on the site itself. So everything begins to make sense once you combine all these elements together, the picture, the terrain, the contours. You now have everything you need right here. You have a good base to work with. And it's all in 3D. It's all in one program. It's all in Rhino. This is how you master the skill of modeling, is to always start with a good high resolution base with every piece of information. Like before, we didn't have this image before. It might have been very weird and very hard and awkward to figure out where things go. Here, literally, this is it. You just know that's a road. Those are the contours. That's where it is. And you can design with that at your base. So this is a very smart, intelligent way of doing that. Any questions about this method? It's a good method.
Probably getting ahead of myself, but curious how one, if they were interested, you would recommend adding, say, like a bridge.
Good question. This one thing, say for instance, right here, you see this area right here, where the bridge of the highway, once it is a structure, the reality of it kind of almost breaks down. You can see like the mesh, the image kind of like follows the train. So this doesn't look very good. So before we get into that, let me do this first. Let's apply the texture to the surface as well, just so that we just have completed that whole thing. So the exact same process. This time, click on the surface, properties, material, match, surface plane. You see the surface in this case, it does a better job of representing it, but it doesn't work exactly because you haven't applied the texture map. So we go to texture mapping, planar mapping, bottom left corner, upper right corner, UV, you're done. So I explained it, but you can see the actual process of doing it really takes seconds once you master it. So now we have the surface with this on it. I'm hit save, just so that we save this work. Now, Trey, to answer your question, there is a little bit of creativity involved in terms of when we get to the point of wanting to represent structures and elements like this. So I'm going to show you one method of doing that. It's a method that you just got to like think in your head, like, how do I model these elements and then also take away this weird look to it? You have to basically go to the image itself, open Photoshop. Maybe some of you can guess what I'm going to do, is you have to manually remove that bridge in Photoshop and essentially create a texture that represents just the ground plane and no elevated structures. So I'll just do a quick example real fast. Hopefully this won't take too long and show you that the process. And luckily this is only going to matter if you are one of the students that decide to do a project with bridges in it. So here's how we do it.
So this is, you don't do the same process for like the buildings. This is a different.
For buildings, yeah, for buildings, what you would do is you would export the actual building footprint shapefile out of GIS. I don't have it turned on here, but then you can have those CAD lines in Rhino that you can extrude and model. So buildings are a lot easier to take care of. Bridges are hard. So here's what you do is, let's say you want to model this thing right here for accuracy purposes and just have it represented. You have to look at this here and you got to say, all right, the bridge starts right there and ends right there. Usually the image kind of tells you just by the color of the road itself where the bridge starts and ends, right? So Photoshop, I told you guys I hate Photoshop, but this is one instance where Photoshop comes in handy, is to fake the funk, as we call it at work, right? Just like find a matching texture somewhere and you just kind of fake it in there like so. Do your best, go here, find this area right here, just select that thing. So then find another area and just like, I hold Alt and Control on my keyboard to like do that. And then essentially what you're doing here is you're just creating a ground texture with no elevated structures. And right here where it gets really tricky, again, you just got to get really creative. You might need to do this in chunks. So you might need to do a little section right here. Find an area that's kind of like that. Copy it over, do your best. You might need to do a little bit of fudging or whatever to make it somewhat accurate. It's never going to look 100% accurate. That's fine. You just need to get it close enough. For the water here, you might take a little section right here next to the start of the bridge, find an area right next to that. It's a little bit weird because it implies that there's trees underneath the bridge, but there's none, but whatever. It's a texture. And then here, just grab that whole thing. Just find an area. Just do something. And over here. So you see, that's all it is. That's all it is. Okay. So you've removed the bridges and there's this one little thing right here. So just take that guy. Actually, it's not just that, it's all this. So you might need to get creative and say like, all right, that little section right there, I pull from that over there. This little section right here, I pull from that right there. That little section there, you move it over. Fake it. I'm doing it really quick, but you would do a much cleaner, nicer job than me. Because he does a little bit of stuff that doesn't look that great, but whatever. Just demo. Well, you get it. So you kind of like create something that represents ground plane close enough. And then you save as, aerial, give it a new name called like ground. Save as a JPEG. Actually, I need to export this out, do a quick export. Export JPEG. Ground. So that's gonna think about it. So then what you do, we have that texture on standby. We have it on standby. So we're going to use it eventually. All right. Like delete this. We don't need this. So I'm just going to delete that guy. Okay. Close grasshopper. So I'm going to turn off everything, but I'm going to leave this little flat surface here first. I'm going to right click on this aerial layer, right click on it, click duplicate layer and objects. So that we create a copy of that. So then you enable, make that the current layer. And then what you're going to do is you're going to go in here, you're going to start drawing some curves. So I'm going to click on the polyline segment right here, and you're just going to kind of roughly trace out. Let me make the layer color like a red so you can easily see it, or like a cyan. There we go. So now you're going to trace out the actual elevated portions of that bridge and try to be as accurate as you can. Again, you would do it much slower. And then you type in split the surface. So you click on the object you want to split and then hit enter. Then you click on the bridge or click on that trim curve, hit enter. So now you've created essentially like a little surface thing of that bridge. So you just do that several times for the other elements. So this bridge right here, just trace that guy. Like you can kind of see logically where the start and end of the bridge is, like right there. Then do that for this little bridge right here. Do for that bridge right there. Let's just go right there. You can see like literally, I'm not really even like measuring, I'm just like literally tracing it out because, you know, we use these bridges and elements for rendering purposes, really. It's not really, we're not using this for construction. So it's okay if it just, as long as it looks more or less accurate. So again, type in split. We're going to split this surface here. So then hit enter, then choose these curves that you drew as your splitting geometry, hit enter again. Now what we can do is you can take this surrounding surface, you can type in hide, and you have these bridges here. So we're going to select these objects here, move them to a new layer, call it bridge surface. So with these layers selected, right click on bridge surface, click change object layer. So now that is where the bridges are. So now what you can do with these set in place, let me delete this right here. You can turn back on either the mesh, let's turn on the mesh here. You can click on the mesh, and now you need to take that mesh, go into the material properties here. You can change the texture image right here, Area 1 JPEG. So click on these three little dots next to texture. Now you choose the ground one right here, click open, and it should just match as long as the texture is the same exact dimension and ratio of the previous one. You'll see in a second what happens. It takes a minute for it to do it because it is a high resolution texture, but it will work. Just give it a second. There it goes. So it just took a second. So now you see the texture swapped out for the one that has with no bridges. And now you just take these bridge elements here. Also, actually, I made a mistake. You see how like the bridge elements below it also took that new texture. So actually what we should have done is this, is hit undo, Control Z to undo it, hit the texture. You have to do this. You have to create a unique editable copy. So click on this thing right here, create a unique editable copy in the material button right here. So click on that. So now you've created a copy of that. So now if you change the texture, it only affects that right there. So now I'll do the same exact process and then go in here, choose ground, click open. And now that only affects the mesh here. So now here's the last part. You take these little surfaces here. I like to turn on this little thing called gumball. So at the bottom of the modeling space, there's this thing called gumball. You see my mouse right here. If you click on that, anything you select automatically turns on these like little XYZ arrows, and that makes it easy to quickly move stuff. So you can just select on these objects, then click on the vertical arrow. So it constrains the movement of that vertically. Then you can also move this bridge here and just kind of move it up. And then all it is at that point is just kind of looking at it and say like, all right. Yeah, that's about right. Then you look at this here and go, yeah, that's almost about right. And then you see it like it's a little bit changing there. So you might rotate it. I believe if you type in points on, that doesn't quite work. I mean, you can just like do a little rotation or whatever, just to slightly fudge it. You know, you just have to look sort of right, and then you've basically done it. Same here as well. Just kind of like see where it is. Like, yeah, that's kind of right. You can fudge it even more just to make it a bit more accurate. That's the quick and dirty way of modeling that structure. Then we can do is click on the bridge structures here, type in extrude surface, extrude SRF. And then we can do, what I recommend doing for this is making, so say not solid. So you see up here, it says direction, both sides, solid, no. Just like, if you try to do this yourself, just like watch the video and try to match these settings. Then all you do is just basically like give it a thickness. So let's say the bridge thickness is 4. So type in 4 and you can see like it just creates a little bit of thickness to it. So now you basically created a bridge surface. Then if you go to say, for instance, to a rendered view where things are a little bit more rendered looking, and it removes some of the rendered outlines, just give it a second, it should. Yeah, you can see it. When you go into rendered view, like it's a little bit more convincing the way it looks. So that took me what, 15 minutes? And that's what your goal is when you're modeling things like context, is you just like, all right, what's the quickest and dirtiest way of doing that kind of thing? And literally it's going into Photoshop, saying, all right, just remove the bridges, having 2 textures, one ground texture and then one bridge texture, and then setting up like so. That wasn't so bad, right? That wasn't so bad. Then obviously you can go back and you can like model things like the underside of the structure to give it a bit more realism if you want. And that's a little bit easier to do. But you see, I didn't really do much beyond just like creating a little surface and then just doing that. If you notice that if I turn off the mesh here, then turn on the surface still has the old texture, right? So what I'll do is I'll click on the surface here, go to the texture properties. Then you can find that new texture that was created. You can just set that to be the texture for this surface here, and then that fixes that. So now the surface has the same texture. That is as far as I really wanted to go for at least this method here, which is just showing you all how to begin to build sites in 3D using these easy methods. And what I would like, you know, all of you to do is like begin to like look at the Montgomery area, find an area that you are curious about, and use this, play around with this method and begin to see if you can like begin to model portions of Montgomery. On Friday, I'll bring the assignment sheet for this next assignment, but in summary, the assignment for this next phase is to zoom into a portion of Montgomery that you're curious about studying and to begin to analyze that from a topographical detail standpoint and begin to build these little models for it. Because I'm a big believer in like setting up the base model first before we do anything else in the design process. So I haven't written the assignment yet. That's why I have nothing to show for that today, but on Friday during studio, I'll bring that. Now, Enscape, that's the one thing we haven't touched upon yet. If you have installed Enscape, the rendering plugin for Rhino, you might have a little Enscape tab at the top here. If you don't see the Enscape tab, but you know you've installed it, you can right click on the ribbon here, go to show toolbar, and then in here, you'll probably find at the very bottom an Enscape thing there. And just want to make sure that the Enscape one is checked, right? So let me save the model first, because we're going to fire up Enscape, and I'm going to show you why it is cool. Q with a K, K-E-K-O-O-L. Okay, so I'm just waiting for it to save first. I always save as many times as possible when I'm working in Rhino, because there's always the possibility of things like failing and crashing, that kind of stuff. So Enscape, start Enscape. There's a start Enscape button right here. So you click on that, click, starting Enscape. Enscape is a real-time rendering program. It utilizes your computer's GPU. So if you don't have a built-in GPU in your laptop, you're not going to be able to, you might be able to, but it won't run as smoothly. So those of you with, say, for instance, gaming laptops or stuff like that, you'll have a good time using Enscape. Those of you with really weak graphics cards will not have a good time. But like I said, Enscape is installed on the Auburn servers. So what I'm gonna do is I'm gonna create a little mini window on the side here so we can see both at the same time. Let me just reduce the size of that thing right there. And then I'm gonna take the Enscape window. Yeah, there's a question.
Just so I understand, so if we use it through the virtual lab, you're then using the virtual lab's GPU, or are you still going to be held back?
You're going to use the virtual lab's GPU. Everything in the virtual lab is virtual. So you don't use any of your own computer.
That's what I was making sure I understood.
Yeah.
Thanks.
Yeah. So hopefully it's, as you can see right now, it's a little bit frozen. There we go. Okay, so here's the easiest way to move around Enscape. In Rhino right here, usually, and also usually like I'm putting everything on one screen. Usually you have multi-monitor, so you might have one monitor for Rhino and another monitor for Enscape. So you just split it out too. Also keep in mind this, there's a little trick. Enscape, like the rendering of Enscape renders to the resolution of whatever the window size is. So if Enscape is running slow for you, just reduce the window size of Enscape. And actually what it does is it reduces the number of pixels it has to render. And that's an easy way to improve performance. Let me close Photoshop. It looks like Enscape is struggling a bit. Okay. So click on, if you in Rhino, there's this little thing called synchronize Enscape's camera position with Rhino camera position. So I click on that. You see that when I navigate around Rhino, Enscape matches the camera position. So this is an easy way to model and render at the same time. So you can see, like, as I move around in Rhino and spin around and pan around, the view in Enscape matches it. But the view in Enscape, as you can see, like for instance, and the water base here, there are no shadows in Rhino. In Enscape, it models the shadows and everything in there. So Enscape's lighting system is very, very nice. You can even see like the highways, like this fake highway thing that I faked a second ago, don't look half bad here. There's a lot you can do with just like a little bit of creativity and faking. And obviously, like later, we'll talk about how to model buildings and that kind of stuff later, but that's another topic. So in Enscape, if you use that match camera thing here, let's say for instance in Rhino, you go to the properties button here, and you have this camera information right here, this thing called lens length. you can change the field of view just by typing that number. So to actually increase the field of view, you create a smaller lens length number, so like 25. So let's type in 25. You can see now that creates a wider angle image, and then it creates a bit more of a dramatic view in Enscape. If I move my mouse over to Enscape, you can also like control and pan around in here as well, but that does not match the Rhino view. So you can choose just to like move around in here by yourself if you want. I think the easiest way is just to do this thing here where you are able to like just match the camera and just do that, but you can choose. Enscape uses similar controls to that of like a video game. So if you play video games, typically what you use are the WADS keys to like move around. And so if I click on the WADS keys, that allows me to move forward and sideways and backwards. So if you like video games, you might actually have fun spinning around in Enscape. But again, you know, using this tool here is one of the easier ways to move around. If in Enscape, my mouse is Enscape, if you hold the Shift key and then hold the right button key and drag it, you can change the time of day. And so this is how you can begin to do some sun studies and dramatic lighting for, say, your renderings or whatever. So you can find a lighting condition that you like, and you can choose that. You see, if I go into like a closer view, you actually see a horizon and everything. You can turn that off if you want. If you don't want the clouds and stuff, you can get rid of that. But in general, like the whole point is this: look at it. Don't look half bad, right? And it was really easy to do. And that's kind of what we're going for. Is we're kind of going for high impact, low effort, and that's what this method provides you. And so you can focus on your designs and ideas. You don't have to be worried later down the road of making it look good for your presentation, because you know it's going to look good, because you know you can give it some dramatic lighting, which always helps, right? Look at that. You can create some nice dramatic sunset views with shiny lighting and all that fun stuff. And just imagine once you put in the buildings and all that stuff, it ain't too hard to achieve a high level of image without much effort. Days of Photoshop are over. You guys are not going to use Photoshop anymore for your renderings. You're gonna learn to model things in 3D, and you're gonna learn to love it, because you're gonna save so much time, less production time, more design time, as we like to talk about. Any questions about some of this basic Enscape rendering stuff? There's a few other things I want to show you. And then for the last hour, I'm going to introduce Infraworks. But this method I wanted to show first, because I think this is the method that I think applies to the vast majority of you, because some of you might not be able to install Infraworks. So not all of you probably will be able to use Infraworks. But even if you don't have Infraworks, you can still use this method using the virtual machines. So that's why I thought this method should be taught first, because it's the one that I think all of you should be able to do. But here's the thing as well: even if you don't have Enscape, you still have this. Like, this doesn't look half bad either. Just the Rhino rendering too. It just doesn't have the dramatic lighting in it as well. So even if you don't have all the tools and fancy visualizations tools at your hand, you still have the foundation of a good site model that you can use for, because this you can just export out, you know, the old-fashioned way through rendering or printing or whatever. But Enscape just adds that little bit of shine and drama to it.
Do you have a strategy that you like for the like vegetated areas that you found to be convincing, like across the other shore? Like, it's kind of just, yeah.
Okay, so let's get into that. Enscape, what's fun about Enscape is it has a built-in vegetation library that is, quite frankly, pretty impressive. And so that's why it's a kind of like a nice all-in-one tool. So let's show you that. So in Enscape up here, we're back in Rhino. Actually, let me do this. Let me close Enscape because just so I can save on my GPU. So whenever you're not doing any, like whenever you're doing modeling work, it's better just to close Enscape and then work in the model. So you don't have to like double up on your resources. So work in the model and then run Enscape. Then you can close Enscape and you can go back. You can also run them at the same time if you have a powerful enough computer, but most of you probably don't. You probably just have my little Surface laptop that I'm using right here isn't that powerful. So I have to do this. Okay. So in Enscape here, there's this tree thing here, browse through Enscape asset library. So click on that. And what it does is it opens up a little window here that's connected to the internet. And it has a bunch of fun assets that you can drop into your model. So what I like to do is in Rhino, I like to create a new layer in Rhino. I'll call that like Enscape trees. Create a new layer, call it Enscape humans, whatever you want, whatever like element you're going to put into the model, just it's good to organize information. So let's create an Enscape tree. So I'll make that the current layer. And then you can go to the vegetation thing here. So click on vegetation. It's always going to be a little bit slow because, you know, it has to like load in all these assets online. But then basically what you do is you can see like Enscape does its best to like organize the assets by tree type or a tree element. And you can just find one that represents what you're going for. It even has these really nasty hedges, but we ain't going to use that. If you want to use this elephant hedge, if I see the elephant hedge in any of your renderings, I will know. Even has these little like turd hedges. So you can use the turd hedge if you like. Sorry. Yeah. So let's go. Sorry, I love potty humor. It's my okay. So let's click on this tree here. And then if you have a surface, there's a difference between surfaces and meshes, but if you have a surface, you can click on anywhere on the surface and it will automatically attach that to some location on the surface. So you can just click, you see that tree automatically pops in there like so. You might need to go back and you might need to scale it up, but you know, let's just drop in a couple of trees real quick. And I'll just show you the result. So there is going to be a little bit of tinkering in terms of like putting the trees down. Maybe let's just do a couple of trees and let's put also a person just to show what it looks like. So you can click on people. This is where I encourage you all just to have fun. So as you're getting used to this, just like play around and see what kind of things Enscape gives you. But Enscape gives you a bunch of different scale figures you can use for the model. So you can see like a lot of women, a lot of men. They try to include a bunch of people in various situations. So it's like it's a full-on comprehensive rendering tool. And so you know, pick a guy that you like and then drop him into the site like so. So there you can see that they come in at the right scale as well, which is pretty cool. You see that's a guy. Let's put a few more guys. Let's maybe put in this mom and her kid. So just have fun with it. And then once you're done placing your assets, you can close out of there. Oh wait, one more thing. Let me do one more thing. Go back to the Enscape cars. You can put cars as well, which is a fun thing to just add a bit of realism to the thing. So go to vehicles down here, and there's a bunch of different cars you can throw into the thing. Like this is where design gets fun. Like it's fun, right? Like before you had to like fake your renderings and like find cars. Like here you can just like have fun, just put your things. Like believe it or not, just like that playfulness of this tool like makes design so much more engaging because like you're just like laughing and having fun and enjoying your time as opposed to like suffering through it. So find a car that you like. And one thing that I really like about Enscape, and I'm sure you will appreciate about Enscape, is you scroll to the very bottom of the car list right here. Hopefully it will load. Enscape, they are very on top of their vehicles, because what I want to see is some of the newer cars that they've added. But the one I really want, so again, these are all loading from the internet, so it takes a second. But the one I really want School bus. Let's add the school bus. Let's add in there. Yeah, school bus. And then you can rotate it and make it like fit the, I say it's this right here. Yeah. What I really want. It just loads. I think it's in the bottom. No, it's not. It's somewhere in here. Where is that? This is worth it. Trust me. This is worth it. There's a reason why I'm looking for it. Ah, yeah. Cybertruck. We all know about the Cybertruck. It's right there. Look at that. So put in the Cybertruck into your renderings. And then once you have your cars in there, now you can fire up Enscape again. Oh, then one other thing you can do is you can take the trees and you can scale them up. So like it scales to the, like it, if you scale them up manually, it automatically like fills it out. So you can, this is how you begin to fill out the environment a little bit. Then you can take these shapes here and you can copy it. So what I do is I move it and then hit the Alt key and that makes a copy. So again, use the gumball command, like you choose this little like move thing here, move it and then hit the Alt key and it makes a copy. So then to go back to Sadie's question, like you can go back here, hit the Alt key and just begin to populate this area back here. You're gonna have to do some manual moving of some objects to make it work. But it's not that hard to do. So you select these objects. You can scale it up, move it up, maybe scale it a bit more. Again, you're not going for realism, you're just going for impact. So just kind of like use the copy tool to really quickly mass out that area, move some things around. Whatever. Okay. Now hit save. Again, save often in case it accidentally crashes. And then once it finishes saving, you'll know it finishes saving when the interface stops freezing and you can actually interact with it. And right now I can't interact with it, so just wait. There we go. Now it's finished. Enscape, run Enscape. What I'll do is I'll do what I just did, which I'll make a small little window like so. Run Enscape. Is anyone following along, or are you mostly just watching? It's fine if you're just watching. It's just hopefully you can test it out. If you're just watching, you'll test it out at some point before Friday, so that you can have some questions about the method. So just give it a second to load. Can you add a train? I'm looking at the chat. I believe there should be a train in there. I didn't read that in time before I added the thing. All right, here we go. So let me, again, I'll hit the little button right here that says synchronized. Oh, if it hits synchronized and it doesn't match, that means you can either toggle it on and off. So I just toggled it off. So let's toggle it back on and now it synchronizes. So let's go, zoom into one of these areas right here. And you can see the trees, that's where it begins to add that little bit of effect to the background. So you just have to increase the density of the that in the background to make it work. But now you can go to the bus here. You can see how that looks. Go to the Cybertruck. See how that looks. It kind of doesn't add it exactly on the ground, so you can just manually move it down a bit until it touches, and you can see that it should automatically update in Enscape on the side.
So there's no way to like apply gravity or like a hard surface resistance to objects in Rhino?
No, that's a good question. No, everything, it's not that sophisticated of a program. That's actually having objects like land on things exactly is a very complicated thing. Enscape does its best by attaching objects to the surface, but you might need to just go back and affix it manually later. You can kind of notice, like, as I'm spinning around here, that when you zoom down to the eye level, it begins to not look as nice because the resolution of texture only can go so far, and it doesn't look as nice. Enscape and these methods are really at its best when you're working at, like, I would say, like a drone level scale. We're kind of just above the site, and you can kind of give that nice aerial oblique. That's kind of what, in my opinion, the best use of this tool is. It's like if we're at this level of scale. And for landscape architecture projects, we tend to work at this scale anyway. But once you get down to the eye level, Enscape begins to break down. So this is not 100% like the best tool for this particular thing, unless you model your own site design custom, like you model your own. If you ever to model your own walls and stairs and elements, then you can zoom in close and it won't look as low res. But using this method of modeling sites, it only really works at this high level here. Again, you can zoom into these people and see how they look. And what's nice about the people is that, it's these people are rendered using photogrammetry, so they don't look half bad in the model view. If I click to go to this woman right here, you can see the woman and her kid. It's not that bad. There's even a little bear right there, which is kind of funny. Yes, and I read a comment, you can adjust the scale of them as well. So if you need to, make them a little bit bigger, you can. But, generally speaking, the scale of the figures as it comes in at a normal human scale. So I don't know why you would make them bigger unless you have a weird reason to do that.
Can you change like the tones and hues of anything? Like, can you get fall color out of this, or is it always summertime in Enscape?
There are some trees in the assets that I believe have fall colored leaves, but you're pretty much limited by whatever assets you have. One thing you can do is Enscape, when you export views out of Enscape, you can export material ID channels and object ID channels, and that just makes the photoshopping process a little bit easier. So you say, for instance, can like get the leaves, and you can easily adjust the colors and turn it into a fall condition if you need to.
Cool.
You can see, like, Enscape is also an animation tool as well. So you can see the leaves actually move. And so you can actually do like walkthroughs and flyovers and that kind of thing. And one of my things I kind of want to challenge you all, and I might make this one assignment, is to do a flyover / video walkthrough of your designs as we get into later in the semester. If you're actually able to model your project in high level detail, you can do walkthrough animations of it, and those are extremely effective. Like a really nice way to represent your project in such a way. Because if you think about it, like, you've sat through many reviews where all you have is a really crappy plan and one really crappy perspective and one section that is so long that you can barely get into it. You just need to get into the design. And so something like a video actually helps accomplish that task. And so that might be one of my deliverables. But I want to see how far you guys get. Like, maybe you don't get that far, and maybe it's asking too much, but a video would be fun to do. Can you change the weather? I want my renderings to look like a Tim Burton movie. Well, yes. So you can go into this button right here, visual settings. Again, this is just all about going into Enscape and playing around. There's all these settings you can play with. Rendering quality. This is one thing you can do is if you set the rendering quality to medium, that reduces the load on your GPU. So you can see things like the trees are rendered a little bit more simple. You can go in images and you can change all of these settings in terms of highlights. So you can, bump up highlights that didn't do much, bump up shadows. I can, adjust the contrast of it a bit. Saturation. So if we remove that bound, you can make a black and white image. Saturation up, you can make a, this might be closer to Tim Burton because Tim Burton likes, does really crazy colorful movies. You can change the color temperature. So right now it's a little bit warm. You can make it cooler. I actually tend to like cooler renderings personally, but again, this is just where you kind of go back and make your artistic choices. There's these fun little effects here like motion blur, lens flare, like lens flare. I think that's only if you're looking at skylight. Well, whatever. Bloom, you play with these tools. Bloom, that adds that soft, dreamy look to it. So another Tim Burton effect you can add is the dreamy bloom effect right there. Vignette, this adds, I believe, a little shadow on the corners. So you can just create that cinematic look where it has this focus towards the center. This adds a weird thing to it. I'm not sure that this is a good way to illustrate what's going on, but anyway, you can play around with the settings here. Atmosphere. You had some fog, so you can increase the fog and the heights of the fog. So that adds a little bit of that fog effect in the background. Might look better if it was like a morning or evening, but yeah, you can add those effects to it. Sun brightness. Anyway, I'm going through all these things here. This is just going through and playing around and seeing what fun effects you can get. But yeah, you can customize the look and feel of this however you like. If you ask me, the key thing that a rendering tool like this provides that makes it easy for you when you're visualizing the projects down the road is lighting. So things like shadows, which are really hard to fake in Photoshop. Like that's what tools like these help provide. It's just that extra level of lighting that makes it easy to visualize because the lighting just does all the work for you in a way. So play around with the tools here and you can have fun with it. You can check this box white background and that gets rid of all the sun and sky stuff if you don't like that, but up to you. Okay, anyway, we can go on and on about that, but we don't have time for all that stuff today. The last thing I will show about Enscape before we close this chapter of the tutorial is exporting out views. So what you want to do is if you go into visualization settings right here, if you go to output, you can define an output resolution. So it automatically defaults to the 1920 by 1080 resolution, but you can go custom and then you can set your own custom resolution, say like 5,000 pixels by 3,000 pixels, whatever you want. And then you can choose the format. You can do PNG, JPEG. These are two ones you probably most likely use. Let's just choose JPEG. And then this is what I was saying is that you can check this box right here. We can export an ID channel, a material channel, and a depth channel. So with all these things checked, you can just basically find a view you like. So I'll find a view. Let's just get a view maybe of like the highway and whatever. Let's change the lighting a bit to make it fun. And then you can click on this thing called screenshot in Enscape. Click on that, save it to your desktop, give it a name, call it test, render, hit save. Then what it'll do is it'll begin to render that image out at that resolution. It'll just take a second or two. Hopefully you all see how easy and fun this is. That's what I'm going for, is like, this is no longer using like V-Ray or other rendering tools. Oh boy. It crashed on me. Ignore and continue.
Hey Frank, did you go to visual settings in Enscape or in Rhino? Where was that?
In Enscape, there's this button right here with an eyeball next to it.
And is screenshot like the official way to render something? Like if you were going to do a final rendering, that's how
Yep.
you do it?
Yeah. Yeah. It seems like a very casual name for that, but it is in fact just a screenshot. I'm not sure this will work just because, you know, it almost crashed a second ago, and I have a feeling with the Zoom call in the background, the Rhino call and the Rhino model here and all this stuff, I might be pushing my resources on my laptop a bit, so it may not work 100%, but that's the method. I apologize if I'm not able to like successfully demo the rendering tool, but it does work. It does work. It just might not be working right now. So let me close Enscape and let me it crashed on me. You can see just Rhino's like automatically closed on me. I'm gonna pause the recording. So now I'm going to show you all a little bit of Infraworks for the last 30 to 40 minutes of this workshop. And then I'll talk about next steps for the studio. So I still have to write the assignment sheet. So you can see the screen, right? So what we do now in GIS is we need to do this first before we do anything in Infraworks. What Infraworks does, which makes it an extremely powerful tool, is it literally takes this data right here and it creates a surface that literally takes each one of these pixels here and turns that into a single mesh cell. So Infraworks is amazing because you can basically render a terrain with no reduction in quality at all. This has its pros and cons. Number one, it allows you to render sites really accurately, but number two, you run the risk of God dang it, me. 1 second. I'm gonna have to do something radical here. 1 second. Unfortunately, Mimi has pushed it too far in terms of like jumping on my desk and creating and interrupting my workflow. So I had to put her out. Sorry, Mimi. Where was I? Infraworks. So again, it allows you to render sites with a high level of detail, but at the same time, it makes it really runs the risk of creating models that are way too detailed. So what I highly recommend doing whenever you're working with Infraworks, let's say, for instance, we want to model a similar area to this right here, right? What we need to do is we need to do something called resampling. So what we want to do is we want to like find this area that we're working in and we want to resample it. We want to basically make the pixel size larger so that we don't overburden the Infraworks tool. So in the geoprocessing toolbar on the side, you type in resample. And there's this tool called resample right here, right? So click on resample and you can input the raster file right here, like so. Then it says an output raster file. You're going to want to actually change the location of this so that it's located somewhere on your folder somewhere. So in this case, I'll just go to Montgomery raster, edit raster, and I'll call this one area 1 test. And then you want to actually add the file extension name to this. So .tiff. You have to type that out, .tiff. So that adds that right there. And then here, cell size. This is where you resample. So by default, this data set that I've given you, the LiDAR ground 00, the cell size is 3.28 by 3.28, which we know is 1 meter by 1 meter, right? So to increase that, you just choose a bigger number. It could be 5, it could be 10. For Infraworks, let's choose 5. Let's do the same 5 by 5 grid, right? And then you can either do one of two things. You can either just run it as it is, but if you just run it as is, it will resample the entire raster as you've seen it here. Or you can click on environments, processing extent, current display extent, which I'm gonna do for this one here, just to save ourselves time, because then it's only gonna resample this area that we see on the screen here. So then you hit
You
run.
want to use the bookmark?
We can do the bookmark, yeah. Go to map, bookmark, area 1. Then choose current display extent again. You see the number update, and then let that run. So hit run. So that took a second. If I zoom in here, you see this is the new cell size compared to the previous cell size. I see it's a little bit bigger. I think this is going to create a nice looking mesh. It is going to be a very detailed mesh still, even with this cell size, but let's work with it. Let's just use it for now. The last thing we need before we do anything else is any kind of mesh surface requires 2 pieces of data. It needs the terrain, which is the DEM, and it needs an image, some picture to drape on top of it. The method that I used in terms of creating the image previously, which is to like export a layout view and then do that. I had to do it for this particular data set because this image data set that you see in the background here, it's running off of a server. It's being pulled, it's pulling the image from somewhere out in space. And so I've tried many techniques and I've tried to find other ways. I have not found a way to hack this, so to speak. So there's no way for me to download this image here. So what we need to do is we need to create an actual GeoTIFF image. And so there is a workaround that I think will work fine. Basically, do the same exact method where we find an area, create a layout, clip it, blah, blah, blah. And you create basically this ground texture right here, right? This PNG. There's this tool in GIS called georeferencing, which allows you to take any picture and align it to a map. So let's do that. So let me go in here, add a folder connection. We're gonna add the desktop. And for some reason, I haven't quite figured out why this doesn't work for me. Desktop. Where's the desktop? Hang on 1 second. Let me just do this. I'm gonna save myself time because I don't know why, for some reason, I've forgotten how to link folders, which is embarrassing. I'm just gonna copy that aerial data into my folder right here. Then I'm just going to refresh this guy. So that's the aerial right there. So I'm gonna drag that into GIS. Hopefully this works because I didn't test this technique before I did the tutorial, so it may or may not work, but let's see if it does. Typically, you would be able to find an actual GeoTIFF that you can download say from a city website or from USGS. And you wouldn't have to go through this whole loop that we're going to go through right now. So added that aerial right there, right? So what we do is you go to the raster. Where do we go? We go to the raster, let's see, imagery tab right here. And then there's this thing called georeference right there. So click on georeference. Then it brings up a georeference toolbar here. So what we do is we kind of generally, let's go to map, bookmark, area 1, go to georeference. You click on this button called fit to display. And it should bring in that aerial to the display. And that worked pretty well. I gotta say, I got super lucky. To fit the display, because we didn't change the ratio of anything, and we just made everything match. It actually just came in the right location. So I got super lucky here. Sometimes this doesn't work as well as I thought. So this is close. This is basically what we wanted. We want this aerial image. You can see that it's the edited image. It was much lighter, less brown. So once you've done that, then you just right click on this aerial here, data, export raster. What we're going to do now is we're going to take this raster that's been moved and we're going to export it again and create an official GeoTIFF. So output raster data set, you click on this here and you just save it in some location. So I'll save it in my Montgomery folder, call this aerial, area 1, aerial, and call it .tiff. You want to put the extension in the name right there. Coordinate system right here, this is the key. This turns it from a TIFF to a GeoTIFF as it has a location. And then everything else you just kind of leave as is, right? And then just hit export. And now you see on the side here, it has added this new aerial, area 1 GeoTIFF. So we've created our data. We've created a high-res GeoTIFF, and we have our area 1 test. These two little ingredients this is our mise en place. This is what we needed. So that was much faster than the previous method. We no need to do like a little fishnet or whatever. So now what we do is we go up into Infraworks. Let me save the map first. Go into Infraworks. So Infraworks, Autodesk Infraworks. Probably my favorite program. So let's open that. It takes a second to open. I have never successfully. I've taught Infraworks for several years, and like literally only one student has like learned it. Like no one cared enough to learn it. Like everyone gave up. But hopefully one of you might find it fun. So here's the basic gist of how to create an Infraworks model. This is what it looks like when you open Infraworks. You have to click on this new right here, create a new model right there. So hit new. That's fine, just click OK. We're not creating Claude models, we're just creating models that exist on our desktop. So give it a name, we'll call this one Montgomery Riverfront. Just get a name, doesn't matter what it is. You're gonna want to make sure this work local box is checked right here. Model extents, in here you can check this box, define model extent, load extent from file, and all we're going to do is we're going to choose one of the raster files that we've exported. So I'll go to the GIS here, and that TIFF file we just created, the aerial TIFF right here, that should work. Yep, so it just works. And then you should just click OK. Oh, coordinate system. Right here. We'll just choose LL84 just to get started real quickly. Yep, and click OK. Just creating a model. Okay, so Infraworks is a whole new interface. You're not going to know anything about this tool. So this is where you just need to have patience and play around with it and get used to the interface. Okay. Let me close this little thing on the side here. So this is what Infraworks looks like. You know, you can see it's just basically a modeling space with a rectangle plane on it. Ignore these like weird lines on it for a second. I'll explain what these are in a minute. Basically what this is if I zoom out, but kind of remember like that's the location. You see we are in Alabama. This whole software is geo-referenced. It knows where it is in the world. So if I zoom out even more, you can see where that's basically where Montgomery is. So zoom back into it, and that's right here. So this automatically knows exactly where it is in the world. What we do is, in order to add data into this model here, there's all these buttons at the top here: manage, create, analyze, present, and share. In the manage tab right here, there is this data source button right there. So that's what brings up this little content panel on the side, on the right side here. And this is where you begin to feed in data into Infraworks. So we're going to add in a few data sets into here and show what it looks like. So the first thing we're going to add is the terrain data set. So what you do is you click on this button right here that says add file data source. You click this little arrow below that, and it brings, you can see all these file formats that you can bring into Infraworks. The one that we're going to use is called raster, which is essentially what a TIFF is. So click on raster. And then all you need to do is just find that. Find the DEM that we created. So I saved in raster data, edited raster, and I called it Area 1 test. If you remember what we called it, Area 1 test. So click open. You see that it adds it automatically into this side on the left with a terrain layer there. Nothing happens yet because what you have to do is you have to configure it first. So double click on that line that brings up a configuration panel. Usually, I would say 7 times out of 10, it automatically puts in all the correct configuration elements that you need. So in this particular instance, it already brings it in as a terrain, and it already puts in the correct coordinate system, which is Alabama 83 east feet. You can see that right there. It knows what it is. So literally, all I do is I just click close and refresh. Okay, this button down here, okay, does nothing. Close and refresh. Refresh is the button that actually does something. Click on that. And so now you can see we've created that terrain. This was infinitely faster than the whole method that we just went through with the whole other thing. That's why I like Infraworks, because it requires a lot less effort to do, but the results are quite nice. Those lines that you saw initially are contour lines. You can see like Infraworks automatically can create contour lines of your terrain model in the model. Also, I would say that Infraworks, it's not as powerful of a rendering platform as Enscape or Rhino, but as a result, it actually runs much smoother overall. Like I'm spinning around this model right now, and it's a lot less choppy. It's a lot less slow than Enscape. Enscape is like a professional rendering tool. Infraworks is a little bit lower than that, but that's actually better for like design purposes. And quite frankly, I like it more. So this is a nice way to render terrain. You can see like it's a very similar quality, if not as good as the other one. And it didn't require any grasshopper, didn't require anything. It just required a couple of clicks and buttons inside here. So what I'm going to show you now is a few visualization settings that you can do. So for now, you can see the contour lines. If you go to the top right of the toolbar at the top, you see this little thing here that gives you these options here. If you open Enscape for the first time, you won't see this thing on high quality, because what I've done is I've created my own visualization settings. So to create your own visualization settings, you click on this button called Add right here, and that creates a new series of visualization options. You can give any name you want. You can call this My Settings. You can call it Wow, I'm great. You can call it whatever you want. It's just a name, don't matter. Let's call it, wow. So much Infraworks, whatever. So me, wow, much Infraworks. So you click on that, and now you have this little thing here where it allows you to adjust things like brightness, contrast, intensity of the sun. You can play with these numbers all you want and just get a effect you like. Sun color, this is one that's kind of interesting. So if sun color is checked, and it gives everything a nice warm image with like blue shadows. If you turn that off, everything goes back to more of a neutral black and white color. So this is just a way you can like begin to customize the look and feel of it. High visual quality, this you can check on and off, and basically what it does is it turns shadows on and off. Wireframe, if you check that, it turns on a wireframe view. You can see like essentially what it does is it's created a mesh. And as I said at the very top of the thing, what Infraworks does, it takes each pixel and it turns it into a mesh cell. That's why Infraworks is great. It does this. And it still boggles my mind that people still to this day aren't blown away by that very fact. How powerful this is. The fact that you don't have to reduce the quality of your terrain to contours or anything like that. You just need to visualize the terrain through this method. It's such a powerful thing to have at your fingertips is that. Field of view and other things, you can just play around with these settings. Field of view, that just changes the angle, the field of view. I like to just leave that at something like in the middle, like 50. And then you can click through these as well. This thing that looks like mountains right here, if you click on that, you can turn contours on and off here. So if you turn off contours and you don't have that, you can turn contours on, you can leave them on. Right now they're at 2 foot intervals. You can change that to 1. And then you can have a major interval as well. So right now the major interval is 10. Typically we do every 5th contour. So if you do 5, you can do 1 foot contours with every 5th one darker. And that's kind of like a very standard way to represent terrain. So it's nice. I'm gonna turn off contours for now. Anyway, the whole point I want to make is that basically you can go in here, make some settings, save those settings, and you can just flip through a bunch of different ways to visualize your model. Another thing you can do, I like to leave the visualization settings turned on for the most part. In the present and actually right here in manage and display, there's this thing called sun and sky. If you click on sun and sky, this is where you can begin to change the sun angle and time of year. So you can see like it just basically changes the date over the year and then also changes the time. This tool is how I do shade and sun studies. And I know that the shade and sun study is geographically accurate because everything is related to that location in GIS. So I like using this tool for that purpose alone. I don't like using any other tool for that. So whenever we're working on projects and they ask like which parts of the city are in shade, which parts are in sun during this time of the year, I use this tool to kind of quickly figure that out. And as you know, like from a planting plan standpoint, you know, you always need to understand like which areas are primarily in shade, which areas are primarily in sun, and that's how you kind of decide what plants go where. Right now there is no buildings, so it's a little bit of a not as fun to see without buildings, but we'll add buildings. We'll add buildings in a second. You'll see how easy this is. Okay, I'm going to pause for a second, and I want to open up for any questions about anything I've done up to this point.
Can you bring, like, if you've built surfaces out of surveys, can you bring those in here also?
Yeah. Yes. You're talking about like TIN files?
Yeah.
Yes. The answer is yes. Civil 3D. Has everyone used Civil 3D before?
I was just about to ask, like how that compares with Rhino.
Well, in this particular instance, because in Rhino we used the 5-foot grid. Here we also use a 5-foot mesh cell, so the comparison between the two is pretty close in quality. but you can go even more detailed. Let's illustrate a point here. Let's do this. I don't think this is a good idea, but let's try it. I'm gonna remove this, right click on it, remove. Then let's turn off the wireframe. Let's go to add raster. Let's add the 1 GB size LiDAR 00 and see what it looks like. You can do this. You can just literally add this whole thing into it. So same exact thing, you put in there, you double click on it to like set it, you hit close and refresh. And this is gonna take much longer to process. The whole point is that, again, you can render sites with pretty much no reduction in quality from the raw data itself, which is powerful. If you have a powerful enough computer to handle it. We started this tutorial at 4, it's only 4:20, and we've basically gone from like 0 to 70 like that fast. I want to emphasize the point that this is way easier than any other method you've probably used in the past and way faster. And that's the
So
whole
why
point.
did none of your students use it?
Because it's too hard and they love Photoshop too much. That's why.
Oh, so it's not like instead of doing this, they're rendering through the Rhino Enscape. It's that they're picking Photoshop instead.
It's because they don't got time and they don't have time to learn. And also because I've never taught Studio before. I've only taught this method in seminars and other classes. So the unfortunate reality of like seminars and other classes is that they tend to take a backseat to Studio. And so students don't tend to invest as much effort and time on work outside of Studio. So this is literally the first Studio I've ever taught, and this is the first time I'm ever teaching this to students. So my hope is that with you all, you'll invest some time as part of your Studio project to play with these tools. And my hope is to just knock the socks off of anyone in the school who has never seen a landscape project rendered this way, because we can't have another Studio with Photoshop site sections and stamped trees, which is a cliche that I don't think is going to lead to new innovative designs beyond what you can do in that. So no tree stamping, that's my rule.
Were you just like so interested in this that you taught yourself, or how did you learn?
Taught myself. And also my company.
I guess I.
Go ahead.
No, go ahead, please.
Oh, well, I was going to just like finish like the company I worked at. The company that I work at has a huge construction component that really buys into the Autodesk platform heavily. And so we just had literally access to all the Autodesk products, including Infraworks. So I had full reign and full like space to play with these tools. And when I learned about this tool Infraworks, I just saw how tightly integrated it was with GIS, and being someone who like loves GIS and loves making maps and all that stuff, I just immediately saw the possibilities of this tool for rendering landscape urban design projects with high level of accuracy, because I was sick and tired of doing everything in Rhino for my entire school career. I wanted something different.
Okay, I guess I might have missed this in as an original question, but did you have a preference between Civil 3D and Rhino, and like why? Or I guess I'm trying to understand, because they're all Autodesk, and so I'm just curious why you would prefer to work with Rhino right now.
Rhino's more fun.
Yeah, but why?
Because that's Grasshopper.
Okay, Grasshopper.
Yeah. I know I'm not really answering your question like with that much detail, but the only reason I like Rhino is because of Grasshopper, pretty much. That's just my personal thing. Like otherwise, it doesn't might particularly offer any significant advantages over other modeling tools. That took a lot longer than I thought, but you can see right here, it has basically modeled the terrain. And if I turn on contour lines, you see you probably don't remember how it looked previously, but this just has a way more higher level of detail than previous. But this level of detail is probably not necessary for it. The whole point is that you can model sites with this level of detail. If I zoom into it, let's turn on wireframe. You see how small these cells are. And if you remember in the model, each of these are 3.28 by 3.28, and you can verify that by using a measuring tool. You can see that this is 3. It's close enough, 3.3 something to something. So you can see that's basically, it's hard to see the number, but it's right there, 3.3.
Hey,
Also,
Trey.
Go ahead.
I was just gonna say, like, my experience with Civil 3D and Rhino is that, like, the difference is that in Civil 3D, you often are still drawing like 2D drawings. It's not that you can't look at them in 3D, but the 3D component seems to be almost like a check. Whereas in Rhino, you have like those 4, like you can see your 3D modeling the entire time. Like it's not, does that make sense? Would you agree with that, Frank? Or is that just a?
I would agree with that. Yeah, like Civil 3D is, as far as I'm concerned, Civil 3D is basically the same as AutoCAD. And Rhino is like a modeling tool. But Civil 3D has the ability to do grading at the same time, which AutoCAD doesn't.
So that, for instance, is Rhino still has, aside from Grasshopper, Rhino has other advantages over, say, SolidWorks, and for the same purpose.
I've never used SolidWorks, so I can't speak to that necessarily. All I can say is that Rhino, and I'm looking at the video, I can see like people are tired, and I can tell this is probably time to end the video.
Yeah, sorry.
No worries, no worries. I know this has been a long class. Trey, I'm not going to answer your question. I don't care about SolidWorks. It's not my problem.
That's good enough of an answer.
Yeah, not my problem. Let's do few more things, and then we'll wrap it up. And then I'll kind of give you all a few things to work on. But the main thing is I want you all to mess with this tool the next day or so. And so by Friday, hopefully I can see that you've tried it. If you have any questions, any errors that you run into, and then by then, once you've got familiar with this method, we'll dive into the project of Montgomery and Greenways. But I want you all to kind of either using the Rhino method and Enscape method, or even this Infraworks method, try to work with an actual site in 3D and be able to look at it in 3D. That's all I'm asking for you to do by Friday, and find an area that you're interested in, whether it's the riverfront or whatever. Let's do one thing, which is we haven't added the aerial image to this, right? So go back to the side here, click on this button, add a raster. And now what you look for is the area aerial TIFF file. So that's this one right here. You can see there's a PNG. This is the one that we copied. And then there's this TIFF that we exported. So this is the one that we want right here, TIFF. You can see the extension TIFF. So click open. Then you double click on it, configure it. In this particular instance, it automatically autofills it correctly. If it doesn't autofill it, you just need to remember what coordinate system we used for this data source. In this case, everything we're doing is Alabama 83 East feet, which is right here. Click close and refresh. Bada bing, bada boom, bada bum, bada boom. And there he is. Way easier. Didn't have to do any of the bounding box, didn't have to do any of the planar texture mapping thing. Infraworks is just easier if you know how to use it. but not everyone has access to Infraworks. Therefore, I have to show the Rhino method. But this method, as you can see, easier. That's why the Rhino tutorial took 2 hours and the Infraworks tutorial took 30 minutes. It's because it's just so much quicker in here. So if you have to find a way to get Infraworks, whether it's buying a new PC or whatever, you can just imagine the time spent, the time saved to get to this point here. Sorry, don't buy a PC if you don't have the money. We're not here to encourage you guys to go poor, but hopefully you guys have money saved up. Okay, so that is the basics of creating that. There's a few other things you can do in Infraworks that's really fun, and I'll try to show that in the next 5 minutes. First thing you can do is you can click on this create button right here, and you can see you can add all of these things in terms of roads, structures, drainage. Let me show the roads thing real quick right here. If you get creative, you can actually create greenway sections that you can just like drape and apply to your model. So let's just click on planning road right here. And I think it might have frozen on me. Hopefully it give it a second. It might have frozen on me. Either that or that's weird. I'm not sure what's going on. Oh, it just took a second. Let's try that again. Transportation planning road. It might just take a second for it to load. I promise this is cool. As always, as everything I show, as everything that I promise you all, it's cool. All right, here we go. So you can click on a road style and you can customize this as well. So if one of you or a few of you master and really buy into this tool, you can customize your own roads. And I'm not asking you to remodel roads, but let's say you want to draw a road, you can do it like that. So you can double click and create a road model inside Infraworks. It's running a little slow for me, but it will work. Just give it a second.
A neat little swimming pool there by that apartment building or something.
Yeah, it's a place where you can all look into the swimming pool, which is how I like my swimming pools. It's weird swimming pools, we can look into it. And then we can do is like you can draw intersections as well. So if you draw another row in the opposite direction, it will automatically resolve an intersection. So for some projects I've done in the past, I have actually created my own greenways, a greenway component. I could just like model it on the actual site, like so. You can see it automatically resolves the grading, automatically resolves the intersections, and you can see in 3D it's actually 3D. That's one fun thing you can do. Delete that for now. Typically, I don't model existing roads because I find that the aerial image is sufficiently good enough for our purposes. Another thing you can do is you can add trees. So in the environment tab here, there's a bunch of options in terms of adding water areas, trees, and that kind of thing. So we'll do a row of trees first, and I'll show the standard trees. So if you click on row of trees, looks like all the creation tools run slow for some reason. Usually it doesn't take this long, but we'll see. So yeah, so what we can do is basically have a whole library of trees. I don't think the library of trees in Infraworks is as good as the library of trees in Enscape, but it's fine. And so what you can do is you can click and draw a line, double click to end it. And what that does is it should create a row of trees like so. So this is how you can begin to populate your site with site elements like trees. And then you can do is you can increase the density. So what that means is if you move the slider to the right, that increases the number of trees in that row. If you click on this arrow here, it can increase the height if you need it as well. So this is a really quick way to begin to populate the site with 3D elements like trees. And then, so I'll delete that. And then the last thing is what's called a stand of trees. So click on stand of trees. And this is where if you want to create, say, like a forest of trees. So a row of trees is a linear element. A stand of trees is an area. So find a tree model that you like this one. Then what you do is you find an area. Let's say this slope here. Let's say you want to model this slope. So click, kind of like roughly draw that out. Then double click to close it. And then it will automatically model that and fill it out randomly with that selected model. So you can see it like so, fills it out. Then what we can do is you can select the tree, select it again to select all of it, increase the density, make it bigger. And that's one way you can begin to mass out areas of forested areas real quickly. So that was a lot faster than, for instance, the little Enscape method. So sometimes when I do renderings, this is one method I use to visualize that. Okay. There's a bunch of other things I can show with this tool here, but I think if there's one thing that I ask, you all try to do is just to get to this point right here, where you have basically a model with an aerial draped on top of it so that you can begin to analyze your site. Because what we're going to ask you to do is actually to pick an area and then begin to do some localized site analysis for that area to begin to think about how you can implement a agreement strategy through this area here. So for instance, if this is my site that I'm looking at here, the question is, how do we begin to integrate and connect, say, for instance, the riverfront park here into a peninsula trail connection over here. So there's a lot of grading, bridging, possibly something of the water they have to deal with. So there's like a lot of issues that we can begin to think about and study and sketch on top of this terrain here. But that's what I ask of you in terms of getting to Friday is just something like this they can use to study. So I'll have the detailed assignment for the next phase, hopefully soon. I just got to write it out. I have it in my head, but I need to write it out for them. Any questions? I know we're all tired. Probably just need to end the meeting. Let me end the sharing. Any questions?
How hard is it to move between Infraworks and Rhino? So like if you wanted to build the model in Infraworks but do your rendering in Enscape, is that possible or not really?
That is possible. That is possible. Okay. You can export the mesh that we created in Infraworks to Rhino if you wanted to. Let's put it that way. So there is a workflow that allows you to take the two. It's not as intuitive as you might think, but there is a way to do it, and I've done it many times. That's the whole secret, is finding a way to create that relationship between GIS, Rhino, Infraworks, then back to GIS, and just create that kind of like workflow loop. And that's where you begin to master time and spaces, if you can like bring that all together. Hopefully you all had fun, enjoyed my little workshop. I enjoyed it. I've been wanting to teach this for a while. Let me think, what else? So on Friday, this was something that not related to Studio, but something that Rob and David brought to me, is that on Studio, Friday is the day of design thing. And they've been talking about having as much participation from our program as possible. So what they suggested was that in the afternoon on Friday, for those who are interested, we might walk over to the Day of Design talk in one of the buildings on campus and listen into one of the speakers. There's like a couple of speakers that they suggested we listen into. One's an architect, and then the other one is a landscape architect. And the landscape architect is the one that I think they want us to show support to. You can participate virtually, so there's a Zoom link you can listen into, but it sounds like David and Rob, they're wanting to like see if like the BLA and the MLA class wants to walk over. So I don't know if you guys got an email or anything about that, but I can send that to who is the LA speaking? Jamie, what's her name? Go to my email. You can just Google Day of Design, but it's like she's an architect at CMG. Jamie Phillips from CMG.
Frank,
Yep.
you're talking about this Friday, right?
Yes, this Friday.
We have also scheduled a parking day for that day. Would it be
Right.
possible for a couple of us to take that time to go to our parking spot to man the booth?
I think that's fine. Yeah. I think that seems to be like a school event that I mean, parking day is a landscape architecture thing. And so who's participating in parking day? Let me ask that. Oh, quite a few of you. Is that
We
a
only
lot?
need like
supposed
a
to be all
couple
of
people at a time. We can schedule it like in shifts.
Okay.
Yeah, we don't all have to be there at once.
Okay. Yeah, I have a feeling that Friday's studio is going to be a mess because some of you are going to be at parking day. And then we have that Day of Design thing, which they want me to be at. So I don't know what's going to happen on Friday, but let's just put it this way. On Friday, you may be out and about, you may be at Day of Design. I will forgive everyone in terms of attendance, as long as I know sort of what you're doing. So if you're at parking day, just let me know if you're at parking day. If you want to go to the Day of Design, just let me know go to Day of Design. If you want to do none of those things and work in studio, work in studio. But don't disappear and run away. Let's just put it that way. Friday's gonna be a mess, a disaster, but whatever.
Is it not required that everyone participates in parking day? Not required, but like Farrell said, like, doesn't everyone work a couple hours of the day? Or is that just the parking day committee? Because there's not really enough of us on parking day committee to be there all day.
We're not expecting everyone to be there all day.
Not all day, but I'm saying like, don't people, like last year, though it was on a Saturday, most people came for at least like a little bit of time.
I think that's the expectation. That's what Charlene was saying earlier, was like everyone is supposed to unless they have a reason not to go. Frank, do you know? Oh, sorry, go ahead.
I was just say Alex has shared a sign up sheet on the SLA group me. If everyone would just please put themselves in for a couple of hours, I don't think we'll have any issues.
I haven't really seen like any information on what's happening exactly since I'm not on the committee. So if you could like post a little something about like what the plan is and what we're doing, that would be great.
Frank, have you heard anything about the awards banquet on Friday evening?
Not much other than I'm probably not going to go.
Okay.
I don't, yeah, I don't know. It's those things like I don't feel like he's like communicated very well by Christian and everyone else. That's like, it's more like everyone's like, please go. I don't know.
All right.
The only thing that I do know that has been communicated to me by Rob is that they